Hello guys, welcome to IAS Bharat. To join our free crash course, fill the Google form given in the description below. Thank you.
Hello and welcome to this series of lectures with IAS Bharat, a unit of Aram IAS. So we are going with the 120 plus club series designed for the students who are appearing for mains and who would be appearing for mains the next years. So within this series, we are completing the GS paper 1. We have done with the society section. Now we are moving to the geography section, which again is one of the most important sections in general studies paper 1. Given the weightage this paper have, this particular section have in the paper, which is 100 marks out of 250 marks, that amounts to 40% of the paper. So it becomes very important for us to focus on this particular sections. So we would try to cover up some of the sections which are important from the examination perspective, and more you can refer to the booklets that are provided under the Do Not Miss Test series. The Do Not Miss series, wherein a large number of templates have been prepared for all the subjects. Different topics have been covered, and within these topics, different aspects have been covered as well. So you can refer to these books as well. Okay. So in today's section, we would start with geography, particularly the physical geography section, where we would cover climatology, oceanography, and sections from geomorphology as well. So just to give you a brief context about the importance of geography section in paper 1. So I've already highlighted the marks section. 2, it is one section covering to which you will get lots of advantages, not only in the geography section, but in other sections as well. Like this will be handy for you in the general studies paper 3 as well, the environment section, the map or the diagram skills that you would be learning here, that would be utilized across the papers. So it becomes very important for us to take this advantage. And we have seen every year that students who are scoring 100 plus or 110 plus marks in the general studies paper 1 are those students who are very good or good at least in the geography section. So we will have to focus upon this section very religiously and in a very disciplined manner. So with that, I think we can start with today's session, where we would be first covering up the climatology section. So the physical geography section, just to give you a brief idea as to the questions that would be asked in paper 1 from the geography section. So question number 4, question number 5, question number 6, question number 7, question number 14, question number 15, question number 16, and question number 17. These 4 10 markers and these 4 15 marker questions will be asked in the geography section. So within this as well, we see that generally 2 to 3 or 3 to 4 questions are asked from the physical geography section only. So given the changes that are taking place in our climate due to climate change, the different weather patterns that are changing, and we are seeing that the global wind systems or the other climatic parameters, they are going under a significant change. So in this background, it becomes very important for us to understand both the static part of climatology, what are its basic components, how the stream of climatology is formed, and then its dynamic part, which involves the climate change and related phenomena that we see in day-to-day news. So the first question that we would be discussing, it talks about the evolutionary genesis of Earth's atmosphere and its vertical stratification. So basically this is a question which can be described as the bedrock of climatology from the static point of view, given that it discusses about the atmosphere, which is basically the study of climatology. It talks about the climate, Earth's climate. So it is important that we have an understanding, the static understanding of how our climate originated in the first place, what actually is climate, what actually is our atmosphere, how it has evolved, whether it was there for always or how did it gradually got into its current form. So basically, this is our planet Earth, and there is an envelope around it, an envelope of gases, we can say, which is surrounding the planet. And this envelope which is surrounding the planet, it is called as the atmosphere. And why it is surrounding the planet? Due to one reason, because basically these are, let us say, this is the climate, and all of it is climate, and there are lots and lots of different gases that are available within this climate. So due to the gravitational pull of the planet Earth, these gases, they are attracted by the planet Earth, and as a result of this gravitational attraction, all these gases are holding up together, and they have come up as an evolution, as an envelope around the Earth. So this is the atmosphere, and you can basically start your answer that what atmosphere is the gaseous envelope surrounding around the Earth, and it is held by gravity. It evolved gradually through Earth's geological history and forms the basis of its weather, climate, and supporting life processes. So all the processes which are related to climate, which are related to weather, they all are originating from this gaseous envelope that we are talking about. So the question comes in mind that how did this envelope, or how did this atmosphere that we are talking about in the first, it came into origin, and how did it gradually shaped into its current form? Then we'll see that there was a whole cycle that coincided with the evolution of the planet Earth as well. So the planet Earth, which evolved around 13.6 billion years ago, which came into origin around 13.6 billion years ago, and it has gone under significant changes after that. And we know that there were different phases that we study in its, the different epochs that we study, the different eras that we study, then the different times within which there were significant changes from its original form to its current form. So basically it was like a ball of, we could say, gases, fire. It was formed out of the nebula, the nebular hypothesis which talks about it. So it was basically that kind of a ball only, out of which gases were escaping initially. And as a reason of this, what was there? So basically it was a gaseous composition only at the initial phase. So it did not had that strong gravity, as a result of which the gases that were there, they were escaping into the space that was there. So the atmosphere was weak. So the first phase, which is called is the primordial phase, within which there were the gases that were primarily available were the hydrogen and the helium gases, and these came from the original nebula of which Earth is formed. So these gases were there, and they were derived from the early solar nebula, and there were intense solar winds, high temperature, and weak early gravity. So due to these factors, these gases, they were not able to hold themselves close to the erstwhile original planet that was taking its own shape. But we see that the planet also evolved gradually, and as a result to that, the atmosphere also got its shape gradually. So this was the first phase, very early phase, that gases were around a solar nebula. So they were escaping into the space, and it was very weak at that time. But gradually what happened, second phase is called the volcanic degassing, which is the second stage of the formation of atmosphere, within which we all know that the initial planet that was there, it was a hot ball made up of different gases which were escaping out in the space. But these gases, when they some of the portions, they were getting solidified as well, and as a result of it, let us assume this was the planet, and this was getting solidified because of the magma that was coming out, the gases that were getting solidified due to its interaction with the outer outer space that was there. But due to this, there were a large the gases that it was holding at that time, they had so much of reactions going on. They were so aggressive in that sense that the volcanoes, the initial volcanoes were, there was a phase when the planet Earth experienced lots and lots of volcanoes. You would see there were only volcanoes all around the planet. So it is at this time that during these volcanoes as well, we see that there were a large number of gases which were coming out of these volcanoes. And when we are talking about the eruption from the volcanoes, then apart from the gases that we are talking, there are large number of other things which were coming out in form of water vapors, in form of methane gas, in form of nitrogen gas, ammonia gas, several sulfur compounds as well. So basically a large number of things it were coming out of the volcanoes at that time, and it was very dense, hot, and almost free from oxygen. So we know that the life of today, it sustains on the presence of the oxygen, but this was not the case always. Earlier in the initial phases, the oxygen was not there as much as we see it today. Then came the phase of formation of the oceans. As the planet Earth cooled, water vapors condensed into clouds. So there came a phase after which the planet started getting solidified, and the gases that were coming out, they got condensed into clouds. Then rain used to take place out of these clouds, and the craters, the earlier craters which were formed during the cooling or the solidification of the planet, we see that due to this solidification, these craters, they started getting filled up, and the current oceans as we see them today, they started coming into shape. Another factor which could be attributed is the biological oxygenation. So we see that the planet Earth, we see all kind different species which are present at the current times, but the composition, the biological composition in the initial phases, it was very different. Basically algae, we can say, the basic algae, the basic cellular organisms which were present there, and basic bacteria, the cyanobacteria, which performed the early phases of photosynthesis. So the planet basically started with very basic bacteria which gradually did the photosynthesis. They started that symbiotic association with some other bacteria, and this is how life started to take shape on the planet. And there was millions and millions of years of evolution, with many of the species coming on the planet getting extinction, whether be it the big fishes that were there, whether the phase of the dinosaurs, or all other phases where many of the species came on this planet and many of them got extinct as well. So this fourth phase which we are talking, it is the great oxygenation event, within which gradual oxygen accumulation. So how did this oxygen came into our atmosphere? Because of a large scale photosynthetic activities, photosynthetic processes that were coming into shape when the cyanobacteria, they started interacting, as a result of which we see that oxygen started to get released into the atmosphere, and we see that the composition in the atmosphere of the gases, it gradually shoot up. Later, oxygen helped form the ozone layer, enabling further evolution. So ozone layer, we all know that it's an important component of the atmosphere, that it protects the planet from several harmful radiations that are coming from the outer atmosphere, be it the UV radiations or several other in the spectrum. It are absorbed by the ozone layer. So you can pictorially represent this thing as well, that how this was the initial phase within which only the hydrogen, helium, they were coming into the planet, and the planet was not able to hold them up. Gradually volcanoes degassing started, and there were some gases into the atmosphere which led to the condensation. These gases, they condensed and started raining, oceans formed, carbonate rocks. Then we see altogether different biological activities when they started taking into shape, and we see that the current position have come into picture. Then the second part of the question, it talked about the vertical stratification of the atmosphere. We all know that there are 5 layers of the atmosphere. You can read the details on your own as well, that this is what the extent of one particular layer from this kilometer to this kilometer. Just for instance, like the initial troposphere that is there. So at the poles, it is like around 16 to 18 kilometers. At the equators, it is around at the poles it is less. So this is the gradient that is observed, and here we see that winds are there. So this is the extent of troposphere. So you can extend sort of read through the extent of these, what which all are the important gases, what all are the important functions that are associated. So most of the climatic studies that we do, most of them are confined to the state of stage of troposphere only, because most of the weather phenomena that happen, I'm not saying all of them, most of them happen within this layer, or the to some extent in the next layer of stratosphere. Beyond that, all the other layers, they do have an impact on it, but the climate that we experience on our day-to-day basis, this is largely attributed to this particular segment or the segment above it. So you can make a simple pictographical diagram as well, which shows that these are the layers. And keep this thing in mind, that while you are approaching geography, you will have to be very presentative in your answers. Try to include, if you are able to do that, at least 1 or 2 diagrams in a 10 marker, at least 2 to 3 diagrams in a 15 marker question, so that you are able to present the content very well. Okay. So you can read through the details of it, the troposphere, second layer stratosphere, mesosphere, thermosphere, exosphere. So you can go through these 3 stages and what are their significance in the atmosphere. Then this diagram, it's very important. It shows the temperature gradient of how the temperature works in the different layers of the atmosphere. So we see that in the troposphere, the temperature, it is high at the surface level, and it gradually decreases, which is called as the normal lapse rate. Normal lapse rate. This is the rate which is around 6 degrees centigrade per kilometer. So as you move above, as you rise in the altitude, then you would experience that the temperature starts to drop down, and it drops at a rate of 6 degrees per kilometer, and this is called the natural or the normal lapse rate. So it decreases, then suddenly we see that the temperature starts to increase. What is the reason of this layer starting to experience that particular temperature rise? Is because of the presence of ozone layer. So stratosphere is the zone within which the ozone layer is found, as a result of which, when the sun rays coming or other sun rays coming from the outer space, they are largely absorbed by the ozone layer that is present in stratosphere, as a result of which there is high temperature in the stratospheric region. Then we see in the mesosphere, which is almost an empty kind of a zone where the temperature again starts to drop down, and at last in the thermosphere, or sometimes exosphere as it is also called, so the outer region, it again starts because of the presence of ions. There are lots of ions that are present within this particular stage, as a result of which they start to react with the incoming solar radiations, or for that matter. So there's an increment in the temperature in the thermosphere. You can conclude that the Earth's atmosphere, it has come into its current shape because of a large scale evolution that has taken place. Second topic that we are talking, examine the modern toolkit of weather forecasting and explain how these tools improve prediction of weather and extreme events. In the light of climate change, we see that the unpredictability that is there with respect to the occurring of many of the climatic or weather related events. Earlier there was some level of or some degree of certainty that was there, that such events would be happening at this particular point of time. But we gradually see that because of climate change, because of many of the other factors within climate change, these things have started to change. They have started both in their extent, both in their manner, as well as in their occurrence and the timing at which they occur. So because of all these things, there is a greater degree of unpredictability that is attached or that is seen here. So we have to, so for us humans to avoid any untoward incident, for occurrence or management of any disaster or disaster related event, what we'll see or what we that we need a better prediction of these events. We cannot stop these natural phenomena to occur altogether. We might be at some day, but the energy that is there in the Earth's system, it will anyways be utilized, and the utilization comes with many of the weather phenomena occurring. So it is the energy of the system, because of energy of this whole system, that these things happen. So we may not be able to control those events altogether, but to a great extent what we can do is we can control the outcomes of it. And how do we control the outcomes of it? When we know the progression of these events. And when we are talking about the progression of these events, it relates to when these phenomena are going to happen and when not. So the timing or the extent of their happening is something that we can get some idea about and prepare ourselves accordingly, so that we are not at any disadvantage. So there are indeed, because of the coming up of the technology, there are large scale changes that are there with respect to the weather prediction. Earlier there used to be their own way of predicting about weather, looking at the clouds, some people having a good idea as to how about the year-long wind systems, that how wind systems, when they change at a particular point of time, there is a likelihood of occurrence of certain weather events. So people used to have an idea, like there are a large number of pre-monsoon events that happen, that there are loos that are experienced in the North India. We see nor'westers, or as they are called as Kal Baisakhi, which happen in the eastern or on some parts of Assam or the northeastern parts. We see that there are certain pre-monsoon events that occur, as a result of which people used to start getting an idea that it is time that monsoon would arrive. So there were traditional ways of doing that, but now times have changed and we have better ways in form of many of the technological advancements that we can do it more effectively. So what is weather forecasting? Basically the scientific prediction of atmospheric conditions using observations, models, computing systems. And basically how these things are done, they are done with respect to certain parameters like humidity into the atmosphere, level of temperature into the atmosphere, several other parameters, rainfall, and other these things. When these things are accounted for, there's a pattern that is observed over the years, that we have observed. if there is any anomaly with respect to the parameters that we utilize in forecasting the weather, so if there is any anomaly at that level, then we would be able to at least get an idea that things might change from this particular point. Weather tools. First is the weather satellites that we have, which monitor the clouds, the rainfall, cyclones, sea surface temperature, water vapor. So basically, they observe the different climatic parameters that are there within the climate as well as on the planet. There's a satellite out there which is monitoring all these things. So this is the level of clouds. They observe the clouds, their density, what is the density of these clouds, and the sea surface temperature, that what is the sea surface temperature that can be seen, and as a result of which they can to some extent they can sense that this is what that might happen. Satellites are there. You can take example of some of the weather satellites that are utilized. INSAT 3D, 3DR, INSAT 3DS. These are different satellites that are utilized. Second is the Doppler weather radars that are there. What they do, these Doppler radars, they detect the rainfall intensity, wind speed, and storm movement. So they are utilized by the Indian Meteorological Department as well. Helps in short range warnings for cloudburst, squalls. So basically what Doppler radars they do is they utilize or they see the rainfall patterns, they see the amount of humidity or several other parameters by which they are able to, in the short term, they are able to predict as to what are the events that might happen. And basically these are the rainfall intensity, the wind speed, the movement of the storm. We see that in the case of prediction of the cyclones, that what is the intensity at which the cyclone is happening. So basically this is a cyclone that is moving on. This is basically a wind system carrying water. So we can see the wind speed, the direction of it, the intensity of rainfall that is happening within this as well. So the movement of the storm, all these factors, they contribute towards the forecasting of these short-term weather events, which includes our cloudburst. We can also say the cyclones as well as the heavy rainfall, thunderstorms that might occur in some parts. Automatic weather stations. These record. So basically these are different modern tools which are utilized. Automatic weather stations. What these weather stations they are used for? They record temperature, pressure, humidity, rainfall, wind speed, and wind direction. They support district level forecast, heat wave alerts, agrometeorological advisories. Used for localized weather prediction and farmer advisory. So what you have to do is basically take 3 to 4 or 4 to 5 such technological tools which are doing which forms the modern component of the weather prediction, and see what they do, how they do, and what are its results. We have seen in the earlier as well that it helps in short range warnings. Second, it is useful for localized weather predictions. So one, we have to take out the utility of it. Two, how it is actually done. This is done that it records temperature, pressure, humidity, rainfall, wind speed, and wind direction. This is how this particular tool do. What it does, how it does, and what is its utility. These are the three principles upon which we would be moving. Next point, it talks about radiosondes and weather balloons. They measure temperature, humidity. So basically all the parameters that are available, all the different, this is our atmosphere. So everything that is available within this, if we are able to measure it, we would be having some idea as to what this thing might play out into. So if there's a weather balloon that we see, if it is moving in the upward direction, it would be having certain sensors which would be detecting the wind patterns, which would be detecting the direction of the wind, intensity of the wind, temperature, rainfall, humidity, and all other a spectrum of all other parameters which are essential in getting an idea as to how this thing actually happens. So these are the radio sounds. They measure temperature, humidity. Such upper air observation help study monsoon circulation, jet stream, cyclone structure. So we have already said that three things: what it is, how it functions, that what it does, that it captures temperature, humidity, pressure, wind at different levels, how it does, and its utility. ठीक है, this is how you ocean buoys and ships they are also utilized in capturing the sea surface temperature and several other, the pressure, waves, winds and currents, the level of the tides, the waves that are moving at the coast or within both at the offshore as well as in the mid oceans as well. They are able to see the changes that are taking place. We know that there are ships which are sent to the Arctic region, which are sent in different parts of the world, which gives that picture as to how the oceans are functioning, particularly in that region, as well as both in the spatial as well as the temporal aspect of it. That when you are into geography, see both the things, especially climatology. One is the spatial aspect of it and the temporal aspect of it. Just to give you an example of it, we talk about El Nino. The spatial aspect of El Nino is that it happens in the southern Pacific Ocean region. What is the temporal? At different times of the year, as well as within the year, as well as across the years, what is the phenomena that is observed. So when we are talking about all these different tools, it gives us that picture of it, that what is the pattern, that the conventional pattern that used to be there, which can be aligned to the natural rhythm of the working of the system. However, if there are certain anomalies, there are certain changes that are taking place, we can also observe them. Digital analytical tools are there. Numerical weather prediction models use mathematical equations to simulate atmospheric processes. Combined data from satellites, radars, stations, buoys, balloons. Supercomputers are there which process the huge amount of data that are collected on day-to-day basis. If let us say there is a weather station or there is a Doppler weather radar that is installed in Andaman and Nicobars, in the Lakshadweep region or on the mainland, it would be giving or continuously feeding data on real time, that at 12 o'clock this was the status of temperature, at 12:05 this is the status, and it changes throughout the day. And this is so much of a data that it would be difficult for humans to account it. So for that matter, we utilize the supercomputers that are there. You can take some of the examples as well, that used Pratyush at the IIM Pune and Mihir at the NCMRWF Noida. So these systems, they are utilized at these places. Okay. They improve the weather forecast accuracy, resolution, lead time for extreme events. And also when we are having these particular sets of data, we are able to simulate that data into predicting as to if this particular set or this particular type of data come into picture, then these are the results that generally are observed. AI and machine learning, we all know that AI has added that layer by which we can see how things can become more effective, in the sense both at the scale at which it is done and the accuracy of it as well. Cyclone intensity, rainfall, nowcasting. So you should, while you are reading again these write-ups, take out the good keywords that are there in the write-up and utilize these keywords when you are writing your answers. So it always gives you that advantage. Early warning systems into color coded alerts, mobile warnings, advisories. We know that now a large number of apps that are there for the farmers as well. And recently we have seen that a alert system was also started in India. When we receive an alarm which tells us about the alert about the weather, if there is any extreme weather event that is about to happen in a particular region, then we will be able to see that thing. Mausam, Damini, Meghdoot, these are the different systems which are utilized by different platforms, which are utilized by different agencies, which feed upon the data on real time, and they provide those feedbacks as well as those alerts on the real time only. Significance reduces. So this is how you can discuss it, that these were the modern tools which are utilized and which are making the weather prediction effective. Observation, modeling, communication tools, satellites, radars, these are the supercomputers which are utilized. And also you can say that how this can contribute towards fulfillment or achieving the goals of the Sendai framework as well. Sendai framework on disaster risk reduction. So this is a framework which was designed, and it talked about that how we have to reduce the number of deaths that are happening. So it had made certain quantifiable datas for each of the countries who are vulnerable to different set of disasters, that how we have to reduce these particular disasters, the outcomes of these disasters on human lives and otherwise as well. Planetary pressure belts are often described as the invisible architects of global climate. Substantiate this claim and assess how their latitude. First part talks about the planet pressure belts are often described as invisible architects of global climate. Substantiate this claim and assess how their latitudinal shift, this is important, under global warming is amplifying weather extremes across different regions. So basically this talks about the changes that are happening into the pressure systems across the world. The theoretical pressure systems that we read about, or the static part of it, we basically talk about that we have low pressure at the equators, low pressure region. Then we see the horse latitude, or at the around 23 degree or we experience the high pressure. Then again is the low pressure belt. Then we see that the high pressure belt at the higher latitudes. So as a result of these, both these are cause and effect of the wind systems that also occur. There is lots of insolation happening at the equator, as a result of which the wind that is there, it rises and it sort of subsides at this. And when a low pressure is created because of when an air partial it ascends, it creates some space, and that is filled by these winds which are called as the trade winds as well. So this would be the direction of it. I was wrong in doing that. Okay. So this is how you can understand the different pressure belts that occur at the planetary level. Then you see that there are certain changes that are happening because of the global warming. So the pressure systems or the pressure belts, they are guided by the availability of temperature into the atmosphere. If the equators, they have higher temperature because of higher insolation, then we will see that a low pressure would be created at the equators. Contrary to this, when we talk about the polar areas which have a lower temperature, that is the cold temperature conditions, as a result of which we see that there is a high pressure zone that exists in the polar regions. So when there is a change in the whole system about the temperature regime of the whole of the system, by which we means that due to global warming, the average global temperature, it is rising to a great extent and at a great speed. When we see this particular thing happening, then the different temperature regimes which were controlling the pressure system and eventually the climatic events that are happening across the globe, we see that this thing will start also having start experiencing some of the changes as well. So it is due to global warming that these pressure belts are shifting. Invisible architects of global eye. How pressure belts, they shape the global climate. So this is the first part of the question, which talks as to how it is, how they shape the global climate. First is rainfall and convection. The equatorial low pressure belt, which is the intertropical convergence zone, causes convergence and uplift of moist air, producing heavy rainfall. And in the Amazon, we know this thing that in the equatorial region, most of the regions that are there around in the equatorial region, they experience rainfall on regular basis. The convectional rainfall that we talk about, that the moist, due to high insolation, the moisture that is present on the surface level, it will rise because of the regular insolation. It will rise, it will condense into clouds and start having the rainfall. So this is one, is this, that it have an impact upon the rainfall and convection. Formation of the deserts. The subtropical high pressure belts around 30° north and 30° south are zones of descending dry air. They create deserts such as Sahara, Africa, Kalahari. So we know that one of the causes of the deserts, so I'm taking half the planet only. This is a low pressure belt at the equator. 0 to 8 to 10 degrees is the extent of this belt. Then we have the high pressure belt. High pressure belt, why? Because the air that is rising at the equators, let us suppose this is the equator and this is the subtropical regions. So air is rising from here, and once it rises, it creates that vacuum here, thus the low pressure systems. And when this air rises and when it moves upwards, and it needs to descend somewhere, it will both move in both the directions and it will descend. It is dry. Why we are saying it is dry? That the moisture that was there within this air, it got condensed into clouds and it precipitated in the equatorial regions only. But the air that is descending at the subtropical high pressure subtropical region, this is dry air. When this dry air descends, what it does is that it creates high pressure. Let us say this is that the air is rising. The dry air is descending in this particular region, and this will create high pressure conditions, as a result of which there is low rainfall in that particular region. So due to this, what happens is that when there is no rainfall, then we can see that whenever there is a rainfall of less than 50 centimeter per year or less than that, then we describe that particular region to be desert regions. Okay. So the formation of the subtropical high pressure belts, what it does, it creates those deserts. We see on the map of the world as well that these high pressures, they create the deserts. We have the examples of Kalahari Desert, Sahara Desert, all on the western margins of on the western margins of the continents. Winds and ocean circulation. Pressure belts generate trade winds, westerlies, polar easterlies. These winds influence ocean currents, upwelling zones, marine productivity. So the whole system, it is impacted because of these pressure belts. We have discussed it, that wind moving from high to low pressure, these wait a minute, let us see this whole system. So this is how the pressure and the wind regime works across the planet. That these easterlies, they are is called easterlies based on the direction from which the air is moving. So we define a air as to be easterly, westerly, or coming to from where it is originating and from which direction it is coming. We describe it as such. So these are easterlies, also called as the trade winds, because traders used to move along these on the ocean surfaces. They used to move along these winds, so called the trade winds. So this is impacting the wind system, one. Second is, it is having an impact upon the ocean currents as well. We know that the regime of the ocean currents that are moving, let us say the equatorial current is moving in this direction. It is moving because these airs, they are pushing the water into these particular directions. When they are having a dragging effect and the water moves in that particular direction, though the intensity or the speed or movement of these water, it will differ across the depth. The upper layers, they will move fast, the lower layers, they will move slow, because there's a whole mass of water that is moving, so it will move at this speed. That this has come from this place, but in the same time it was able to move to this far. So it is having, and as a result of which, upwelling zones, marine productivity, we all know these. So this is the interconnection that is there, that this is a whole system which is functioning as a unit, and changes in one part of it, it will have a compounding effect, thus changes across the system. So this is how this whole thing goes. Cyclones and storm tracks. Subpolar low pressure belts guide westerlies, temperate cyclones, bringing rainfall to Western Europe. So a bunch of phenomena, weather phenomena that happen across the world, we see it is as a result of these things happening. These pressure regimes, these wind regimes that are functioning across the planet. Latitudinal shift under global warming. We all know that global warming is causing the headless L. You must be knowing that this is the headless L. Then we have the Farrell's headless L, Farrell's L, then the polar cell that is there. So basically this wind coming from here, moving here, subsiding here, at the upper layer we are talking about. This is what happening. There is a system that is, so a cell has been created here as a result of, there is this whole bunch of systems that is moving in this manner, and there are changes or there are shifts that is experienced within the extent that they used to exist at this particular latitude. At, let us say in January, it used to be here. In let us say when it is summer, then it will move northwards. During the winters, it will move southward, because it aligns with the movement. It is caused by the pressure systems. Pressure systems are caused by the temperature regime. Temperature is experienced on the planet Earth by the sun. So with the movement of the sun, we could see this thing happening. So headless cell expansion will be there towards the pole, subtropical highs, westerlies, storm tracks. So this whole system undergoes significant changes as a result of all these things happening. ITCG also becoming more variable, making tropical rainfall and monsoon less predictable. We also seeing that many of the cyclonic events that used to happen, for instance, I am taking the example of the Indian Ocean only, that the unpredictability of these events happening has risen to a next level. We are seeing that they are happening at the different times of the year. The extent, the intensity of these cyclones, it is also very different at different times. Amplification of weather extremes, drought, heat wave, and wildfires. Let us look at the question again. It talks about how they are architects of climate. Second, substantiate these claims. Their latitudinal shift is amplifying weather extremes across the different regions. So the third part that we'll see is that how it is amplifying the weather extremes, droughts, heat waves, wildfires. We are seeing that thing happening in be it in the sub-Saharan Sahel region, that we are seeing that there are large number of droughts that are happening. Also, we are seeing that in many parts of the world there is an acute water crisis that is seen or that is visible in at different times or at different places that we see in. We also see heat waves happening. You can take the examples of European countries. They are experiencing a temperature of around 35 to 38 or somewhere around 35 degrees centigrade. As a result of those are the people or those are the climatic conditions for which 35 degree was not natural. All the ecosystemic activities, the species that were there, they were sort of adaptable for a different temperature range, not the one that they are experiencing in the form of heat waves, heat strokes. There are large number of health related challenges that the people from these regions are experiencing. We are also seeing that many of the species, they are also undergoing changes as a result of these heat wave events. We also see wildfires happening. We can take the example of Australian wildfires that was there. The Bushman fires, I think it is called. The Bushman fires, or the fires that happened in Australia, or also in parts of United States. We see that some of the wildfires, they are taking place. Also in the South American regions. So we see that these things, these extreme events, they are amplifying and they are on an increasing trend. Second is the erratic monsoon that we take. We are taking this with a regional approach, that we are taking different regions and the impact of these changes into the pressure regimes. What are the impacts it is having regionally? So first is the droughts, heat waves, wildfires. We have taken an account. What you can do additionally here is that you can make, okay, I'll do that by the time we discuss all these 4 points. Second is the erratic monsoon, that is. So monsoon is a phenomena which is basically nothing but a seasonal reversal of the winds. That wind are flowing in a particular direction and they are an extension of these pressure systems only. This is somewhere India is above, of course, above the equator. Somewhere it is India. Then this is South Asian regions. During the north, when the sun goes to the northern hemisphere, what happens is the sun goes to the northern hemisphere, and as a result of these pressure systems, they also shift and they come as the equator also goes above. So the whole system goes into the north direction, and these winds, these trade winds which were earlier flowing till the equator, now they start flowing beyond this. But what happens is, this is the geographical equator. When winds move beyond this, what they do is, when they enter the northern hemisphere, they'll start moving into the right direction because of the Coriolis effect. So Coriolis effect is also having that impact on the monsoon coming into India. Had this been the case, the winds would have flowed only in this direction. But due to that shift, that the rightward shift that it is taking place, we see the monsoons happening. So what is happening because of the changes in these pressure shifts or the pressure belt changes? monsoon onset, withdrawal, and breaks. So one of the timing of the monsoon, basically for India, it becomes very critical. That till now India experience around 75% of its rainfall during the 4 months of the monsoon only. So if there is anything that happens and that leads to the reduction of the monsoon rains, then it will have a direct impact on all the aspects of human life that is associated with the Indian people or those residing in the Indian subcontinent. So it is very crucial that these monsoons happen. But due to the unpredictability that have come into the pressure systems, thus the wind systems, we are experiencing that unpredictability in the monsoons as well. As a result of which, we see that a large number of changes, be it in agriculture, fisheries, and all sorts of other things, we see those changes. Withdrawal of the monsoon, all those timings, they would be affected, breaks in the monsoon. So what happens is, it's not that wind will start coming and it will go on. There are breaks that are there in the monsoon. That wind, it rises, it carries moisture, and it goes. So there are breaks as well between the monsoonal rains as well. In South Asia, it causes long dry spells followed by intense rainfall. So we are seeing that these flash rains that are happening, these cloud related events. So that these are the types of extreme weather events that happen. You seeing thunderstorms, then suddenly lots of rainfalls. You will see cloud burst happening in a particular region. Then there's a whole period for which it is absolute dry conditions that are existing. Extreme rainfall and floods. Next is the warmer air holds more moisture while altered pressure gradients intensify convection. This results in cloudburst, urban floods, extreme precipitation, especially in tropical and mid-latitude regions. So this is a whole spectrum of the extreme weather events that occur, and that also depends on the latitudes within which they are happening. We are not going to experience tropical cyclones, let us say, in the middle or the higher latitudes. That will happen in the lower latitudinal regions only. But there will be different weather events that would be happening because of changes in these wind systems or the pressure systems. We would be seeing that cold winds would be there in the higher latitudes. We will see that there will be breaks in the jet stream that flows, be it in the mid latitudes or in the higher latitudes. So there will be breaks that would be happening because of global warming. And when there is a break in the jet stream, then it will lead to certain extreme weather events happening in those. So we can changing storm tracks and cyclones. Poleward movement of westerlies alters temperate cyclone path in Europe, North America, and South Ocean regions. Similarly, warmer oceans and shifting convergence. So basically, this is a whole account of all the changes that the world or the planet is experiencing due to global warming. What you can do, that as we were discussing earlier, basically just make a map of world. You can just draw it and show what are the different weather events that are happening across the world. You can talk about the monsoonal phenomena here, monsoon here. You can also talk about the heat waves or heat strokes here. Can also talk about here as well the global heat dome that is that is building in this region, you can talk about that as well. Wildfires in case of Australia we can talk about. So you can give a regional account of the events, the extreme weather events that are happening as a result of the shift in the pressure regime. So this is how you generate the diagrams. When you are talking, let us say about, when you are talking about the monsoonal point, then just make a brief diagram of the Southeast Asian and Asian region, within which you are able to show, or in which you are showing that how this particular region is getting impacted. When you are talking about the heat waves point, then briefly mention the European region, that how these regions are getting impacted because of these events. Coming on to the next question, it talks about analyze the frontogenetic origin, life cycle and meteorological significance of temperate cyclones. So basically this is a question on temperate cyclones. We'll have to start our answer by defining what is a temperate cyclone. So basically a temperate cyclone, these are extratropical in the sense they are formed in the higher latitudes. Tropical is the low latitudes. Something that happens beyond these low latitudes, that is extratropical, that develop in the mid latitudes, generally between 35 and 65 degree latitudes. They are associated with fronts, westerlies and contrasting air masses. So there is this whole phenomena of the formation of a temperate cyclone that we would be discussing. Analyze the frontogenetic origin, life cycle and meteorological significance. So the frontogenetic origin of the formation of the temperate cyclone. So there is a 6-step process that was described by a geographer, that this is how a temperate cyclone is formed, then how it evolves, and then how it gradually fades. So just to give you a context, these extratropical cyclones or temperate cyclones, they are different from the tropical cyclones that we experience in the lower latitudes. These temperate cyclones, they are larger systems compared to our tropical systems that we experience. These are larger in extent. They move for a very long distance for about half or a complete component when they are formed. So there is a different region for the formation of these temperate cyclones as well. Meeting of the contrasting air masses. So one of the reasons that this thing would happen is that the higher latitudes, which is the cold conditions, and the lower latitudes, which is having the hot or the warm conditions, when the winds, because of shifts in, it can happen at both the times. When the warm air, it marches into cold air, or when the cold air marches into the warm air. So this is why they are formed in this mid-latitudinal regions. So there's a possibility that wind from the lower latitudes or the higher latitudes, when it will move on the planet, it will somewhere converge at some places in the mid-latitudes. The first step in the formation of the temperate cyclones is the convergence of these contrasting air masses. When the warm and the cold air masses, they converge in the first step, called polar and warm tropical meet, this zone is called as the front. So when these air masses meet, this particular interaction point where this is meeting, this is basically called as the polar front. Then this formation strong temperature contrast. Then the second step that goes is the strengthening of these fronts. Have mixed different densities that do not mix easily. The boundary forms warm front and the cold front. Weather changes occur mainly along. So what happens is that after the interaction, it is not so that these airs, they will mix into each other. This does not happen because of the contrast that is there in these airs. So what basically happens is that in the second stage, when These these are dense airs. These are cold air, warm air. Cold air is always dense. This is less dense. So it marches into, sorry, this cold air which is heavy, which is at the surface, it marches into the warm air. So when this air marches into this will start uplifting instead of mixing into this. And when we are talking about mixing, it's not that it is not at all mixing or it is completely mixing. Some of it might mix. And when we talk about the mixing of these air masses, we'll see that certain weather phenomena is happening because of these interaction. So this will form that cold air will march into the warm air, and there will be whole gyre that will be formed. And as a result of which, we would see a cyclone like condition. First, meeting of the contrasting air masses. Second is the front, the surface or the boundary where these air masses meet is called as the front region. Role of the westerlies. Temperate cyclones generally move from west to east under the influence of the westerlies. So it is very important that when we are talking about this particular region, which is 35 degree to 65 degree, what happens is that this is our easterlies to 0 degree. This is where I hope you are getting a context that how this is how the air masses are moving. It is within this zone that we experience the formation of the cyclones. It is here that we experience the formation of these cyclones due to the different air masses. Under the influence of the westerlies, which is the air moving in this zone, this will be carried into this direction. So these cyclonic system, they will start marching into this direction, and it is very obvious that when such climatic system they march from one particular place to another, then during its course there will be a large number of interactions happening both into these contrasting air masses. The warm air mass, they would also be carrying certain moisture. When this system would be moving, there will be certain water bodies that would be falling in their way. Let us say this is the American region, and it is here that this temperate cyclone has formed, and it started moving toward the European. Then this is the Atlantic Ocean that was there. Then we have the Europe. So it picked up moisture from this Atlantic. It must be having its own moisture as well. And when it will land onto the European landmass, what it will lead to? It will lead to the occurrence of rainfall in that particular region. So this is the third step, role of the westerlies. Next is upper air support. Jet streams and upper air convergence. It help identify the surface low pressure. So this is half the planet. These are subtropical jet streams, and these are higher latitude jet streams. So jet streams are basically wind systems which moves at a very high speed, basically at let us say at the height of troposphere only. So this exists at the troposphere only, and they move as a ring around the planet with a great speed. So these systems, they will also have an impact upon the extra tropical cyclones that we are talking about. And we have discussed this thing earlier as well, that how due to the changing in the pressure system, these jet streams that we are talking about, they will also undergo a change, and they will also undergo a change because of these shifts, and thus they are having an impact on these cyclonic systems as well. Both they can carry these systems. When just to give you an additional information, that when there is rainfall in India during the winter season, what happens is that this is India. Go from here, this is the Middle Eastern region. Then let us erase this thing. Just to give you an example that how jet streams they work, this is Africa, this is the Mediterranean region. What happens is, during summers, the Mediterranean sea that was there, it sort of acquires that temperature, and due to this, there is obvious that there will be evaporation that would be happening. So that water, it gets down cool as well as hot very slowly. So during the winters as well, there is some amount of evaporation that is going on, and due to the shifting of the pressure system, due to movement of the sun in the southern hemisphere, what happens is that the jet streams which were earlier in the higher latitudes, they move to this region, this Mediterranean belt, and they see that there are clouds which are formed above the Mediterranean, which are carrying some rainfall. And these jet streams, they are anyways moving across the planet, around the planet. So they will carry these mountains along with them. They will drag them. And we see that when these mountains, they come over, these clouds, when they come over the Indian region, they precipitate the rainfall. So this is the mechanism of the winter rainfall in India. It is caused by, so such are the impacts that it have on the extratropical cyclones as well. Life cycle of a temperate cyclone, you have talked about it. First, the initial stage, stationary front develops between warm and cold air masses, that the two fronts, they'll come at a point. Second is a well-developed low-pressure center forms. A low-pressure system would be formed. We don't have to confuse the extratropical cyclones with anticyclonics. Those are different conditions. Anticyclone is a high-pressure system. However, cyclone is a low-pressure system. These also happens in the higher latitudes, and we sometimes tend to confuse them with the extratropical cyclones, which are temperate cyclones as well. These are two different things. Cyclones are systems which have a low pressure at their center. So because of the convergence of these air masses, warm and cold air masses, the system will be formed, and there will be a low pressure at the center of it. Mature stage, low pressure center would be formed. Strong winds, clouds, precipitation around the system. Occluded stage, the faster cold front catches up with the warm front. Warm air is lifted completely above the ground. So we have discussed this thing, that how the higher, the denser air mass, it will march and sort of occupy the area of warm air as well. And as a result of this, the warm air that was there, cold air, it marches into its area, and this will go like this, or they'll interact this way, and they'll form a system, and then started circulating due to the Coriolis effect as well. The warm air lifted completely above the ground, the cyclone begins to, this is the fourth stage, occluded stage. Till the mature stage, what happens with the temperate cyclone, that it completely forms, it will precipitate, and it will have a range of weather related phenomena happening. After that, the faster cold front catches up with the warm air is lifted, cyclones begins to be. So there will come a time when these two different contrasting air masses, they'll start exchanging their energies with each other. Gradually it will start eating up into each other's energies and neutralize at some point. So it is at this point that when it starts getting to neutralize, we experience that the temperate cyclone has started to dissipate or weaken. Then comes the dissipation stage. Temperature contrast reduces, pressure gradient weakens, the cyclone gradually loses energy. So basically it is a result of the exchange of energies only that we see these things. Weather conditions associated with these. This is the second part of the question. It talks about warm front weather. Warm air slowly reduces over the cold air, And we have seen that there are a range of weather related events that would be happening. The formation of clouds, then rainfall. Initially it will be gentle. When the system will intensify, we will see that the rainfall is also getting intensified and gradually it dissipates. Cloud sequence includes cirrus. These are different clouds that are formed. Cold weather front. So basically what they're doing is that they've described the weather events at both the cold front as well as the warm front that is there. At the cold front, what happens is it forcefully lifts the warm air. So thus it forms the cumulonimbus clouds. So नहीं, I have the what? बस नया है कि आप अपने पास है? So these cumulonimbus clouds, which are associated with extreme weather events in the sense that there will be intense rainfall that would be happening around these. There will be large scale thunderstorms, lightning, and all these extreme weather events that would be going on. Thunderstorms, heavy showers that would be taking place. Third, the occluded front weather, when the system starts to lose its energy, and when it gradually becomes a system which is in a stage of decline, we see this thing happening. Complex cloudiness and rainfall, it gradually becomes colder after so this is that how this system loses its energy. Meteorological significance: rainfall in the mid latitudes, Europe, Northern America, Chile, New Zealand. When we are talking about it, it happens in both the hemisphere. It is not that in the northern hemisphere only that this thing is happening. It happens in both the hemisphere. Okay. Snowfall and blizzards. Colder regions, they produce snowfall and blizzards. Heat transfer. This is a great mechanism of transfer of the heat. You must be knowing that one is this, that between the latitudes there is a heat transfer, that the colder or the higher latitudes, they transfer that to the lower latitudes, and the lower that does to the higher latitudes. And how that is done? That is done both with the air and water. The ocean currents is one phenomena, two is the air. And we can sort of also say that these are having an impact upon each other as well. Indian relevance: temperate cyclones originating near Mediterranean region. They bring winter rainfall to the northwestern. We have discussed this whole mechanism by which the rainfall, they are caused in the pockets of India during the winters. Are frontal disturbances, thus, yes, we can say that. Okay. Next question, it talks about elucidate the processes of condensation and precipitation and explain the major forms in which precipitation reaches the Earth's surface. Elucidate the processes of condensation and precipitation, and then explain the major forms in which precipitation reaches. So basically it talks about, first you'll define that what is condensation, then precipitation. This is what you can do in the introduction part. Condensation is when the water that rises and forms into clouds. This is the process of condensation. Then when these condensed clouds, they cause the precipitation. When we are talking about precipitation, it's a larger term with respect to the water again moving to a next stage in form of rainfall, also sometime snowfall as well, and they also have different forms with respect to their intensity, the drizzles, heavy showers, everything that is there. Process by which water changes into water droplets or ice crystals. It occurs when air becomes saturated. So you must be knowing the dew point concept. So dew point is the stage at which the water, it sort of condenses into the clouds. Requires tiny particles, condensation nuclei such as dust, smoke. So whenever there is a ice particle or a rain particle that is formed, it is formed around some condensation material. And that is the reason that we are seeing that in some of the cities which are highly polluting, we are seeing that there are sometimes sudden rainfall that are occurring. Why that is occurring? Because there is large number of pollutants in form of the SPM particles, the small particulate matter particles that are there, or some others soot from the pollution and from the different fossil fuels that so there's a whole range of things which are present into the atmosphere. And as a result of this, what happens is that the moisture that was already present into the atmosphere, which have come up from the evaporation from the vegetation, which is called the evapotranspiration sometimes, that the evaporation happening from both the land as well as these vegetations, and a combination of all these things, it leads into this presence of moisture and the particles. Thus you would see that there are sometimes these droplets are formed very suddenly, and you would experience some very sudden showers in some parts of conditions of condensation, sufficient water vapor in the air, cooling of air below dew point. So this is the point at which the rainfall happens. This is 100% humidity. Saturation of air due to cooling, evaporation, and mixing of air masses. Forms of condensation. What are the different forms of condensation? First is the dew. Dew forms when water vapor condenses on cool surfaces like grass, leaves, and we have seen that. So condensation is basically when the water reaches the water vapor was that there into the atmosphere. It reaches into the state of water, into water droplets, into ice crystals, or anything. So dew is one form or one manifestation of condensation that occurs when there are conditions for this. And I think it is very important that you have an understanding of these conditions, that the night have to be calm, that there is no wind that is experienced, because if there is wind, the water vapor, they will not be in a position to condense at the surface level. What it needs, that when the air is present, let us say when the water vapors are present, this is the ground level, and if there is a calm night, cold night that is there, then the water vapors which were present at this layer, the surface layer, they would find some place or the other. It could be a tree leaf, it could be something else, where they would find that place around which it will sort of it will coat around, and it will condense itself into. So it's not that all the water that is there, it goes into clouds and it forms clouds only. It can condense at the surface level as well. So it is very common in the winter mornings, because the wind movement is less, the nights are very calm at this point of time. Frost forms when water vapor changes directly into ice crystals. So it depends upon the temperature of the atmosphere as well. So if the temperature is too high, that is below the freezing point, then let us say, or below the 0 degree centigrade, then we'll see that the water vapor or the moisture that was present in the atmosphere, it will condense into small ice crystals, which would be called as the frost conditions. Fog would also be formed. Tiny water droplets near the ground reduces the visibility. Again, this is caused by the presence of the particulate matters at the lower level or around the surface, because of which the visibility also reduces. Mist is similar to fog but less dense. Visibility is more than fog. It usually occurs near rivers, lakes, coastal areas. Kolkata, the city of Kolkata, it experiences lots of mist conditions around it. Clouds are also when the moist air rises, cools, and condenses. So the moisture, water vapor, or the moisture that was left beyond this superficial level, and when it goes at the higher level, due to the normal lapse rate, what happens is that water gradually starts to cool down, and it will reach at a stage when when it will find the favorable conditions for its formation into clouds or into droplets. Forms of condensation. Second is the precipitation, is the falling of condensed moisture from clouds to the earth's surface. So if condensation was the accumulation of water, it will again bring that water down. Precipitation, it occurs when cloud droplets or ice crystals grow large and heavy enough to overcome air resistance. So when they become too heavy for the atmosphere to hold, let us say if there was a small particle, so there is this whole cycle of formation of a water droplet as well, but that again is a topic which we generally discuss in the geography optional, that the hygroscopic nuclei has to be there. It is around this particle that water will start getting accumulated gradually, and it will start condensing in the sense that it will start taking in the shape of water or ice crystal. But that does not qualify this particular droplet to be called as a part of rainfall. It will happen as such when this water droplet, due to accumulation of more and more moisture, it will reach to a stage that it will be difficult for the atmospheric resistance or the atmosphere to hold this particular water droplet, and this will descend and lead to precipitation. What are the conditions? Presence of moisture laden wind, uplift of cooling air, formation of the clouds, growth of droplets through collision, coalescence and ice crystal processes. So these are the different processes by which the rainfall droplets or these things are formed. What are the different forms of it? Rainfall is one, so the basic. Second is the drizzle. Third is the snowfall. When precipitation falls as ice crystals, it is called as the snowfall. It forms when atmospheric moisture temperature remains below freezing point. So this is important. You'll have to remember that if there is a normal rainfall that is happening, then the water has condensed and it is falling when the temperature was above the freezing point. If it is below the freezing point, then alone this then it qualifies to be called as snowfall. Okay. Next is sleet. Sleet is a mixture of rain and snow or small ice pellets. It forms when falling snow passes through a warm layer and then refreezes before reaching the ground. So I'll just make a simple diagram for you guys to understand it. Let us say you must have seen that during the winters or in some pictures or at some. So this was basically a tree which has this branch. So this was a tree. So during night time, what happened that the water, it accumulated around it in this form. It accumulated, this is the water. This is the ice that accumulated around this branch. Okay. But due to a little change in the temperature regime, this water, it start to melt. But before reaching the ground, this was so quick that before reaching the ground, it again got condensed. So it is like this. You must have seen these things. These kind of water droplets that are there. Basically, this is sleet, mixture of rain and snow or small ice pellets. Hail consists of hard balls or lumps of ice, forms in strong cumulonimbus clouds with powerful updrafts. It can damage crops, vehicles, houses and aircraft. So these are formed. So when the updraft, what is updraft and downdraft? So these are updraft. Whenever a cloud is formed, there are two phenomena that happen. This is downdraft. This is a cloud that is formed. Why this cloud is formed? This was formed because water vapor was rising in form of evaporation and this cloud was formed. So it is the intensity of this wind that when it goes at a height, it will start cooling because of the normal lapse rate, because at 6 degree per kilometer the water will start cooling, the conditions they start cooling. So it raised to this stage, then it got sort of condensed into small droplets and became a cloud. But if the updraft, it also depends upon the updraft or the intensity of the wind which is carrying it. If it is strong enough to carry this beyond this level as well, then we know that if a particular object it moves at an even greater height, then it would experience even more colder conditions. As a result of this, what will happen, that these small droplets, they will start, these were small droplets. So the updraft is this movement of these water vapors in the upward direction. When these small droplets, when they will move, they will start becoming big droplets, because one is the intensity of their moving within the cumulonimbus cloud. Second is the amount of water that would be accumulated, and they will form into big hard balls. So these are basically the hails that we see. When they'll move downwards in form of precipitation, this time it can be described as a process around condensation only. But when it will start precipitating, the temperature, it will start losing the temperature, thus it will start reducing in size as well. So the hails that we experience at the surface level, it is not the exact size of the balls that they were formed in the clouds. So they have reduced as well this much size, then because of temperature decrease, they'll come down as small balls. So this is hails. Second is the freezing rain. When liquid rain freezes after touching a cold surface. Types of rainfall. There are 3 basic types of rainfall that are experienced. First, the convectional rainfall. What is convectional? Intense heating of Earth's surface. We have discussed about it when we are talking about rainfall in the equatorial areas. So basically this is convection. Convection is the movement of air into vertical direction. When air moves in vertical direction, this is called as convection. And when air moves in horizontal direction, this is called as advection. Okay. So when moves in upward direction, what happens is that it carries certain moisture from the surface, and it will start uplifting that moisture, and it will reach at a stage when this water will condense into clouds because of the normal lapse rate. That with decrease in temperature, what will happen, what we will see, that this will start condensing. As a result of this, clouds will be formed, and when they'll become heavy enough, they will lead to precipitation. So this is the convection. Due to movement of moisture, clouds are formed, and then it is basically the condition is that water or water vapor, it has to condense to form into precipitation. Okay, so this is one type of rainfall which forms due to the water moving in upward direction and then gradually condensing. Second is, so you can take the example, it is found in equatorial regions during the summer thunderstorms that are experienced. Second is the orographic. Basically, this is around any physical barrier. We generally associate it with the mountain area, but it is something that can happen against a plateau as well. So any physical barrier that is there. This is the Western Ghats. This is Arabian Sea. Wind was coming, carrying the moisture, but when it started to rise, it will start losing its temperature. This water vapor, this will start losing temperature, and clouds would be formed gradually, and they will yield rainfall in this part of the mountains, and thus called as the orographic rainfall orographic rainfall against a physical barrier. This is the rain-fed side, windward it is called, and this is the leeward side, because what happens is this air, it came into this direction, and it doesn't mean that it will stop here. It will come into this direction, but what will happen is that it would have already lost its moisture, and it would not be carrying any moisture further from here. Thus it will come as a dry air, thus no precipitation, thus the leeward side or the rain shadow region. Okay, this is the second type of rainfall. Third is the cyclonic or the frontal rainfall. We have discussed during the temperate cyclone that they occur when warm and cold air masses meet. It's not that it necessarily have to be in the mid latitudes only, but that is when it generally happens. But whenever two contrasting air masses, they meet and they form a front, which is the boundary between the two, they leads to, due to this interaction only, it will lead to the precipitation of the moisture. Condensation, precipitation are essential atmospheric processes that transfer moisture within the hydrological cycle. So you can also connect it with the current changes that are going in this whole cycle. Because of climate change, because of global warming, because of rise in the sea surface temperature, and a bunch of other factors because of which these things are happening. Next is describe any four major world climate types and highlight their climatic features, vegetation, and human adaptations. So these are static. I need not sort of discuss all these things in detail, though we can do that. But basically this question, it talks about the different climatic regions or the different climates that are found across the world. So just to give you a brief, you can make this diagram where you can divide the world in this way. This is 30 degrees somewhere, monsoonal region, the savanna region, hot deserts. No, this is not the monsoon region, sorry. This will be the equatorial climate. So this is a sketch diagram which talks about the different climatic regions of the world. 0 to 30 degree equatorial, 0 to 10. This may vary in these cases. Equatorial, savanna, hot desert. Then there will be the monsoonal climate. Then this side there will be Mediterranean climate. So there are different climatic regions that are formed across the world. Then there will be the cold climatic conditions. We have the cold deserts as well present. So you can present this way. Tropical monsoon climate. The first, what you have to do is that first discuss the climatic features of that particular climatic regions, one or two characteristics briefly. Tell about as to in which regions they are particularly found, that Bangladesh, Myanmar, Thailand, parts of West Africa. Then what is the natural vegetation that is found in these regions, in these particular regions, and how humans are adapting to that. Just to take an example of the tropical monsoonal climatic conditions only, we see that dense population due to fertile plains, agriculture. Tropical savanna climate is the second climate that we have discussed, found between equatorial and the desert regions. It is seen to be in the African regions, wet summers, dry winters. Then third is the tropical desert climate that we experience between 15 and 30 degree latitudes. So this is The next, how humans are adapting, are sparse and concentrated. So it will depend upon the climatic conditions as to what would be the presence of different natural vegetations, different species that are present. One, two, that how humans are adapting to those different or those particular climatic conditions. We would see that thing as well. Steppe climate, it will be experienced in parts of the South African region. We know the steppe grasslands that are there. Different grasses are found, the small grasses, then the big grasses. So there is whole bunch of these variety of vegetations which are found depending upon the climatic regions. So all you have to understand in this particular place is that you are understanding the climatic conditions, why those particular climatic conditions are formed. We have taken example of some of them, like in how the monsoonal this whole thing works, how in the mid latitudes rainfall are caused. So when we would be reading about vegetation and the causes, that how these vegetations are formed, then we'll get an idea as to how these different vegetations they are found. Depending upon the different vegetations, how different animals they are found, and so on. These things go on and on. Okay, so you can discuss and read about these things in detail. I think that will take lots of our time and less of an understanding. It will be just a repetition of facts. So we are moving on to something that we can discuss. Explain the mechanism of Coriolis effect and describe how it influences the direction. Mechanism of Coriolis effect and describe how it influences the direction of winds, ocean currents, and cyclonic circulation in the two hemispheres. So this, it will start with the basic description about the Coriolis force. Basically, when we are saying that it's a Coriolis force, it is basically a deflection of the wind that we see. It is an apparent force that is caused because of the rotation of the earth. So this is our planet Earth tilted at around 23 degrees around, and it revolves like a ball around this particular axis. So this is the direction. It moves from the western to the east. This is how it revolves. And when it revolves at a great speed, we experience this Coriolis deflection. You would experience that when you revolve a great ball and try to put something at it, it will deflect as a result of that thing moving, that movement of that ball. So basically, this is the simplest by which we can go. You can describe is an apparent deflection of moving objects due to rotation of the earth. It does not create motion but changes the direction of winds, ocean currents, and cyclonic systems. So this movement of the planet Earth, it causes that deflection. Then what is the mechanism of this particular force or this particular effect? First is the rotation of the earth only. Due to its rotation, the moving air, the water appear to get deflected from its original path. Is called as the Coriolis. Second is the direction of the deflection. So there is a law which talks about, this is 0 degree. This is the northern hemisphere. This is the southern hemisphere. So what happens is that whenever, due to the Coriolis deflection, if we are seeing a Coriolis deflection, it is observed that in the northern hemisphere, anything that is deflected, it always moves to its right direction. So this is how we represent it. How right direction? If it is moving from this direction to this direction, let us say this was a air partial which was supposed to move from this place to this place, then it will not directly go to this place. It will deflect to some extent towards its right. It is, I think it is called the Farrell's law, which talks about that how it deflects into the right direction. For the southern hemisphere, they are deflected towards the left. So this is, if it is supposed to move this direction, it will move into this direction. For a air partial coming in northern hemisphere only, to avoid any kind of confusion, let us do it in a better way. This is how it goes. For something moving from the northern to southern direction it will move into this direction. In southern hemisphere, it will move towards its left. Are you able to observe something? That it is because of this law, it is because of this deflection only, that the trade winds that we were talking about, that they are coming from the higher, the subtropical high pressure belt around 25 to 30 degrees. When it is coming towards the equators, which is the ITCG zone, it is coming in this way. It is due to this Coriolis deflection that it is coming, and thus the whole things. Direction of deflection, variation with latitude. Coriolis force is 0 at the equator and it increases towards the poles. Hence cyclones, they do not generally form near the equator. So the speed of something moving at the equator and that moving at the poles, there will be a great degree of difference in that as well. So what happens is that there is this principle as well, which that something that moves very fast is something that will experience more deflection. So if something is moving at, let us say, 100 kph, then it will experience a greater degree of deflection than something that is moving at 50 kph. So this is one difference as well, is 0 at the equator. Coriolis force or Coriolis deflection is 0 at the equator and it increases as it moves towards the poles. 0 at the equator and it moves towards the poles. So it is because of this zero, the availability of Coriolis force, that we do not experience the tropical cyclones at the equator. It is not that we experience it around 0 to 7-8 degrees. We do not generally experience. We experience that in the Indian Ocean, in the Arabian region, Arabian Sea region, in the Bay of Bengal region, and not exactly at the equator. It is because of this deflection. Because how cyclones are formed? Cyclones are formed when, let us say, this was the wind which was moving in one direction. Then what started happen, because of the strong speed, low pressure that was created, this wind started circulating and started forming a gyre type of a situation where it is moving in a circular position. As a result of this, what happens is that a low pressure is created. So this low pressure is created because of the circulation of this whole system. Dependence on speed. So we have discussed this particular thing. We have already discussed that how this deflection takes place. Okay. So this is the speed at which the earth rotates. Okay. Influence on the winds. What influence this Coriolis deflection have on the winds? First, the trade winds. We have discussed that how these trade winds are a result of the Coriolis deflection. Westerlies in the mid latitude regions. These are polar easterlies, these are westerlies, these are again easterlies, which are called as the trade winds. These are deflected because of towards their right because of the Coriolis deflection. Take. Moving on to the next, the jet streams as well. Their path meandering are strongly influenced by Coriolis force as well. So we experience that these, when the jet streams or the high speed winds, when they are rotating around the earth, they also to some extent they experience this deflection. And when they experience this deflection, we know that the jet streams, they move in this manner. They are not masses of air which revolves like a ring, but they have certain meanderings that are there, and these meanderings are caused by the effect of Coriolis deflection only. It is these meanderings also which determine the climatic conditions in different parts of the world. What are the influence on the ocean currents? First, surface ocean currents are deflected by Coriolis force. In northern hemisphere, they turn towards right. Okay. Let us take this example, that the currents that are moving, let us say they are moving in this way. They'll deflect to their right, they'll deflect to their left. This is the simple principle. And we see that in all the currents. When it is coming, when this is forming a complete cycle, you would see that it is deflecting to its right only. This will form this complete cycle and it is deflecting to its right only. It is not that there is some magic happening, but it is due to the movement of the planet Earth that this force is created, this deflection is created in such a way that it always turns to that direction, and such is the case with the southern. Ocean gyres, they help form large circular ocean gyres, rotate clockwise in north, and this is that. We have talked about it. If this is an oceanic gyre, then it moves in clockwise direction in the northern hemisphere, and it moves into anti-clockwise direction in the southern hemisphere. And this is what happens with the anticyclones. Anticyclones are basically high pressure conditions which are formed in the higher latitudes. So this is an anticyclone which has formed. This will happen with the anticyclones as well. This is a high pressure situation from which air is moving out. Air is moving out. This has to be a natural way of it moving out. But what will happen if it is in northern hemisphere? It will deflect this way, this way, towards its right. If it is in the southern hemisphere, then it will deflect towards its left. Thus, cyclonic and anticyclonic. So this is how you can understand this whole thing. You can see that with the help of example that these formation of these gyres, movement and deflection into the left and right positions. Influence on the cyclonic circulation. Oh, we have discussed it earlier only. In the northern hemisphere, cyclones, they converge. So there will be difference within the cyclone and anticyclone as well. You should understand this thing as well. I am talking about northern hemisphere. You can go to the southern hemisphere and do that exercise on your own. This is a high pressure situation. This is a low pressure situation. In northern hemisphere, low pressure system, air moves towards this center. From high pressure, it moves out. The law is that in northern hemisphere, it will move towards its right. It will move towards its right. It will move towards its right. Right. So this will form this way. You will experience this thing in a cyclonic manner. In a clockwise manner. Similarly, talk about an anticyclone. This was the direction of, in case of cyclone, this will be in anticyclone, towards its right. Yes. I'm sorry. This will be in anti-clockwise direction. So there was a mistake in the diagram only, that it will move in the clockwise direction. You have to see this only. These are the arrows. They'll deflect to their right, and towards the clockwise direction, and in this case it will deflect to its right, thus the anticyclonic conditions. So this is what is written as well. As a result, cyclone rotate anti-clockwise in northern hemisphere. In southern hemisphere, what happens? Due to deflection, it moves in the clockwise direction. For what happens with anticyclone, it is just the opposite. That in the northern hemisphere, you would see an anticyclone moving in a clockwise direction, and in southern hemisphere moving into a anti-clockwise. Absence near the equator is very weak near the equator, therefore cyclone rotation cannot develop effectively. This is how it happens. Anticyclone, then cyclonic conditions. Moving out clockwise, moving out anti-clockwise in southern hemisphere, and this is what happens. Next question. Explain the mechanism of ocean atmosphere coupling in tropical cyclone genesis. Critically examine, first part is explain the mechanism of ocean atmosphere coupling in tropical cyclone genesis. Critically examine how climate change is altering their frequency, intensity and tracks. Suggest measures to reduce cyclone related vulnerability in coastal regions. Is the coupling of atmosphere and oceans. So basically what cyclone is, it's an interaction of the atmosphere and the ocean only. When the atmospheric wind or the air, when it interacts with when the atmospheric wind or air, it interacts with the oceanic water, these systems, they are generally found to be formed. Their genesis depends on atmosphere coupling, where ocean heat supplies energy and atmospheric circular organize in a rotating system. So basically this is a system, and each system runs on certain energy that fuels the system, that makes it functioning. So what makes this system functioning? This is our ocean, this is our atmosphere. It will have air, which we have talked about, the advection, the horizontal moving air. It have water. What happens in water, that due to rise of the moisture due to evaporation, it will have that energy. So basically this is an interaction that it provides that direction through wind, the movement of air, and it provides that energy to this system. How it provides that energy? When these air, it will move, and when they will converge into two, due to the moisture that is present, it will provide that energy, and due to this presence of moisture, this air will start rotating into a system of low pressure, which we generally called as a cyclone. And the intensity of this cyclone would entirely depend upon how it provides and how much energy is provided to this particular system. So it is because of this reason only that when these cyclones, they make a landfall, they are cut off from their source of energy, which was the water moisture that was there. So when it is cut off from after the landfall, it gradually depletes. And if it is formed in the innards of an ocean, and if it has traveled for a long distance, then you would see that the intensity of that particular cyclone, it will be very high. 1, 2, if the sea surface temperature, if it is very high, then also the system would become very intense. Okay. Warm ocean as energy source generally require sea surface temperature. So there are different conditions, particular conditions which are required for the formation of a cyclonic system. So first is this one, that the sea surface temperature, it has to have above 26 or around 27 degrees centigrade, you can write. Warm ocean increases evaporation and supply moisture to the lower atmosphere. This moisture becomes the fuel. Second is the latent heat release. Latent heat release. Moist air rises and condenses into the deep convective clouds. Condensation releases latent heat, warming surrounding air column. This lower surface temperature pressure. So why this low pressure is caused between these cyclonic system? In the cyclonic system, we would see this thing, that moisture was supplied to the system. It revolved, it rose, it moves in horizontal direction, it gradually develops into vertical direction also. When this, due to updrafts, when this water moisture, it moved upwards, it gradually started condensing and started forming cumulonimbus clouds. So generally, if you have to discuss the extreme rainfall events or intense rainfall events, then that is generally associated with a type of cloud which is called as the cumulonimbus clouds. So this is exactly what happens in a cyclonic system, that these cumulonimbus clouds are formed. When these cumulonimbus clouds are formed, water condenses, and when water loses that heat, it is the latent heat of condensation. So this heat is released and supplied into this system, and this system will feed on that energy and keep on moving. Latent heat release, and the more the latent heat release, the more the intense and strong system, cyclonic system, it will develop into. Next is the positive feedback mechanism. What is the lower pressure pulls in more moist air, more inflow, causes more evaporation, condensation. So this system survives on this thing only. Why it survives mostly on water? That this low pressure system, it will attract more and more in wind. And due to this wind, what will happen? More and more will be attracted towards this center. After this, it will supply more moisture. There will be more condensation, more latent heat release, and this is how this whole feedback thing, this whole chain completes. Coriolis force and rotation. Next is that how Coriolis force, it sort of provides that deflection, provides that initial circulation to the wind, that it gradually develops into a system that rotates at a great speed. Next is the low vertical wind shear. Weak vertical wind shear allows the cyclone to remain vertically organized. Strong wind shear disrupts the system structure. So if the speed of the wind, if it is very high, then it will not let the system develop vertically. ठीक है? Weak vertical allows the cyclone to remain vertically organized. Strong, it disrupts that whole structure. If it is, the cyclone would only survive if it is connected to its source. The moment you disconnect it from the source of moisture or source of water, you will see this thing happening, that it will gradually start declining and thus dissipating very gradually. Next is the ocean heat content. Not only ocean surface temperature, but deeper ocean heat matters. High ocean heat content prevents rapid sea surface cooling during storm passage. ठीक. So please go through the diagram of a basic tropical cyclone as well, because it's an important topic from the geographical perspective, from geographical understanding, and for the understanding of several other climatic phenomena which happen due to these cyclones. So this is low pressure system, which is called the eye of the cyclone. It forms as a vertical system. So this is the eye wall of the system. Then this is a whole big system that forms in such a way. You'll have the ascending air, the descending air, then rainfall within these, cumulonimbus clouds that would be formed in between. So this is a whole system. Make a basic sketch of the tropical cyclone. So whenever you are discussing about in whichever answer, please try to inculcate this particular set of diagram. Climate change and tropical cyclones. What are the changes that have been experienced due to climate change? First is the frequency of it, uncertain but regionally changing. Climate change may not uniformly increase the total number of cyclones globally. Low confidence in. So what has happened is that there was a report by IPCC on oceans, which provided this data that of the total heat that is released into the atmosphere, what happens is that when this is in a system, due to climate change, we all know that due to different human activities or other anthropogenic factors, there is lots of temperature that is rising, and around 90% of that atmospheric temperature that is there, it is absorbed by the oceans only. These oceans are the destination where this temperature is being absorbed. So if that happens, and that surely doesn't happen that it will be uniform in its absorption. There will be areas which will absorb more, and there are a large other number of factors which are also responsible, particularly when we are talking about cyclone. So when the sea surface temperature will rise, we have already discussed that high sea surface temperature around 27 degrees centigrade that we are talking, then there is high probability of formation of a cyclone. We have seen that in case of Arabian Sea, we have seen that in case of Indian Ocean, that more and more cyclones have started to come up. On the Arabian coast, earlier what used to be the data, that this is the Indian landmass, 1:4 or 1:5 is the ratio of the formation of cyclones, which is gradually changing because the oceanic system, it is getting heated up, and as a result of that, more cyclones coming up. So this is one reason that the frequency, it has changed. We have taken example of 1:5 to which is changing. This is the frequency that earlier you could experience only one tropical cyclone on the Arabian coast, but now that is not the case. You are experiencing 2, sometimes 3 as well each year. So that frequency of occurrence have also changed. Second is the intensity, the destructive potential of the cyclones. We have seen that more the favorable temperature conditions that are there in the ocean, we will see that these favorable temperature conditions will feed into a system. This will generate a cyclonic system which would be everlasting, and its intensity, it will be even greater because of a simple cause, that this whole system operates on the latent heat energy, and that latent heat energy would be supplied due to high temperature in the oceans. So that is causing the intensity. We can connect it with that how different agencies across the globe, they are telling that the global climate, rise of the global climate, and we are also seeing that each year we are experiencing the hottest year of from the past. So this is a serious thing that we need to think. Rainfall, wetter cyclones. Warm air hold more water vapor, therefore cyclones now produce more intense rainfall and flooding. So they have taken this example of cyclone Montha in 25, causing very heavy rainfall and flooding. When we are talking about cyclone, this is not a system that only operates, that it generates, it operates and then gradually dies in the ocean only. This is a system which goes and make a landfall and it impacts human living, it impacts human habitation. So we have to be aware of the fact that more the frequency of the occurrence of a cyclone, more is the intensity with which the cyclone occurs, and more the water that it is able to hold because of higher moisture content caused by higher global warming. If all these things are coming up together, then the cyclone as a natural phenomena, it will gradually transfer, or it is transitioning as well into a natural disaster because of the severe impacts that it will have upon the people and the planet. Tracks shifting and uncertain pathways. Climate change alters sea surface temperature gradients, subtropical highs and steering winds. This influence cyclone genesis, zones and tracks. So what has happened is that earlier we were able to map out, or we were able to track as that. I'm just taking a hypothetical situation, that if a cyclone is formed around the Andaman and Nicobar Islands, let's say in Bay of Bengal, then due to Coriolis deflection, that the system will move somewhere around Odisha and all that. But what happened in recent years, that due to variations in the sea surface temperature, the variations that were observed, this is an oceanic system which will feed upon higher temperature, higher moisture, higher latent heat. So wherever it will get that supply from, it will transition to that route only. So if this would have been the natural course, because of the favorable conditions, this is the actual route that it is following. We are not very sure in sometimes, though technology have enabled us that we are able to do that tracking on real time. However, the challenges still persist, that tracking all such oceanic systems with accurate precision and with 100% accuracy, it has become a challenge in the recent times. Compound risk. Cyclone is increasing through the combination of storm surge, heavy rainfall, sea level rise, coastal erosion, saline intrusion. So these are the impacts of a cyclone that you can mention. Storm surge, when the cyclone makes a rainfall, the situation forms. Heavy rainfall will be there, sea level rises, coastal erosion. Saline intrusion, the salt water, it will be imputed in the freshwater resources into the agricultural fields that are available in the coastal areas. Flooding, it will also increase in the coastal areas. What are the measures to reduce cyclone vulnerability? Strengthen early warning system. We have already discussed in the initial of our discussion that we are not in a position to stop these phenomena to occur altogether. Where will you take this energy otherwise? When we are not able to stop these phenomena, the best way at this time we could come up with is to mitigate its impacts that it is having upon human lives. First is just have the information when it is forming, how it is moving, when it will make a landfall, and that can be done with the early warning systems. We have discussed a whole range of these technologies which have come up and which have assisted us in such forecast, be it the Doppler radars that are there, or the utilization of satellite systems, or supercomputers, AI and machine learning systems, which are giving us that exact blueprint of the cyclonic or these oceanic systems, of how they are coming up. It strengthens early warning systems. Climate resilient coastal infrastructure. We have to focus that the infrastructure that is made, it is strong or resilient enough that it is able to absorb the shocks that would be there after a cyclone. We can make certain zones, certain zonation with by which we can categorize that what is the nature of the settlements that could be made, or that can be made across the coastal areas. Coastal zoning and land use regulation. We already have coastal regulation zone rules in case of India. So a better implementation of them is also necessary. As long as we are not following up the norms properly, then things would stay as it is because of the brewing population, because of the emerging requirement of coastal areas coming up as important tourist destinations. So if the infrastructure and other things they go unchecked, then we might face certain issues. Ecosystem based protection, we have to restore the natural ways of absorbing that shock. Basically, if you are able to absorb that energy and that shock at the coastal area only, then this thing will not happen. And that can be done by natural ways. Make the sand dunes, grow some grasses on them, make the sea breakers that are there, which are stones which are put up across the coastlines, and they are able to absorb that energy. Most efficient, most eco-friendly way to promote, to conserve, to promote the mangroves, the different species of mangrove trees that are there. So basically they absorb that whole intensity of these cyclones. Community preparedness have also to be there, that people are made aware of all these things. Cyclone evacuation systems have to be there. There have to be a proper rehabilitation, sheltering of the people that should happen. Livelihood and agriculture resilience, we have to promote saline resistant crops. We all know that we have to devise systems by which we could do agriculture, be it the Kuttanad agriculture practice that is practiced in Kerala. So that is a below sea level farming that is happening. So we can come up with certain other innovative ways by which we are able to do this particular thing. So this was a whole set of questions that we talked about climatology. There are other important areas that you can also discuss with respect to this year's examination or the next year. Please do go through the El Nino concept. I'll give you a brief idea about the El Nino concept. So you need to have what is El Nino. Second is the Madden-Julian oscillation phenomena. So basically things that impact the Indian monsoon. It is asked many a times that what are the different factors which impact the Indian monsoon. So these are some of the recent trends, some of the recent phenomena of whose understanding we are able to develop in these periods in the recent times. Madden-Julian oscillation, El Nino oscillation systems. So you need to go through them. What are their impacts on India, and how can we deal with all these things? Just to give you a brief about the situation in this is, I'm just making a brief sketch of, this is India. You'd see Australia here. Sorry. You will see Australia somewhere here. So basically El Nino or the ENSO system, which is El Nino Southern Oscillation, this is a system which occurs in this area only. What is it? The natural course is that there is cold water coming up, which is the Humboldt current that generally goes. As a result of this Humboldt current, there are cold conditions in this situation. When there are cold conditions, air will not rise. So this is generally a high pressure condition which are observed at the surface. And at this, we are taking a larger picture here. And this is the movement of trade winds. We have already discussed that this is how the trade winds, they move. This is 0 degrees, the 0 degree equator. It is these trade winds which goes and form the cyclones. It is upon this particular area or this system that most of the things depend, that what are the conditions available to here. If it is a high pressure, and what happens that gradually due to a phenomena that if it is cold here, cold water here, then it will be hot water here. Gradually this hot water, it increases, and whole of this thing, it turns down to a hot water condition. So when it is cold, then it will be La Nina conditions, high pressure system and La Nina conditions. And whenever there are La Nina conditions, then there will be a high pressure situation here. So the air moving, the trade winds which gradually will make up the Indian monsoon, when they are moving in this direction, they have no impact, because already it is a high pressure system and this is a low pressure system. So when winds start moving in this direction, this region will only assist these winds to move away. Some of the winds, they will also start moving away, and thus it will be a favorable monsoon here. Just revert the condition here. We are talking about El Nino conditions, when this whole system have become a hot water system, thus low pressure, because if there are hot conditions that are available in, or warm conditions available in this condition, in this particular system, then air will start rising. As a result of rising of this air, so there is a Walker cell that develops in whole of this. So this air will start rising and this will move like this. So rising of this air, there is a low pressure, it is here. So when this wind would be moving in this direction, some of it will be attracted to this because of the physical distance. Some of the air, it will be attracted to this low pressure system. Basically, air moves from high pressure to low pressure because of the pressure gradient that it follows. Okay, so this is what happens when, let us say, 30 to 40% or a big part of this air moving, which was moving every year, it is taken and absorbed in the Pacific region only. Then there will be less wind, thus there will be monsoon breaks. That would be there will be the withdrawal of the monsoon. It will also be early, and thus a weak monsoon in the Indian conditions. So you can then chart out all the impacts that it has. Okay. So these were some of the questions that we discussed about climatology. Now we are moving on to the next section, which again is very important, the geomorphology section in physical geography. So basically physical geography, it comprises geomorphology, the study of land surface, topographies and all that. Climatology discusses about climate, weather and all related events. Oceanography talks about ocean mechanisms and different other aspects related to oceans. Then we have biogeography, which basically talks about the biotic component of our environment. Then we have environmental geography, which talks about the integration of all these, the atmosphere, basically the biosphere part, where it talks about all the components of environment and surrounding. Moving on to geomorphology, basically this will have some important themes within it, which they many a times ask. Either they will talk about some topographical feature. Within this topographical feature as well, which are mountains, plateaus, plains. These are some of the topographic features. Within this topographic feature, how they are formed, what are the processes by which they are formed. Several, after these topographic features, there are some other phenomena which are also talked about, which are some, we can say something related to earthquake, volcanoes, how these things are formed, what are the mechanisms that run behind them, how these are formed, and what are their impacts. Next thing that they can ask you about is a larger study of these, which is the formation of continents, the oceans, and their movement, which is basically the theory of plate tectonics. Plate tectonics, they generally ask a question on plate tectonics every 2 to 3 years or so, or they repeat this in one, they have asked in 25 only. Discuss the cosmological postulates of Big Bang theory and explain the major evidences in supporting. This is, I mean, it is the starting, I would say. This is one thing from which we generally start the study of our geomorphology, or how the earth came into picture and all these things. But this is not an area from which generally questions will be asked on the Big Bang theories. Even if they ask you, they can ask you that how the current earth, it came into its this current shape or current form, how it was formed and everything. Then you can discuss about the different postulate, the nebular hypothesis, this Big Bang theory, and all these things. But there is no separate question on these things as such. So we won't be wasting much of our time here. Instead, what we will do is we'll discuss something else. Discuss the layered architecture of the Earth's interior and explain how direct and indirect evidences help in understanding. This is a good topic. This can be asked as well, the study of interior of the Earth, because a large number of things, they are decided by, or they are happening because of certain activities that are taking place in the interior of the Earth. Why am I saying that? Because the very fact that the continents or the ocean floors, they are at a position or they are in a state of movement, it is because of the internal activities of the Earth only that we experience these changes. We all know the different layers of the Earth. I think they must have provided a diagram for this as well. Yes, this diagram is provided, where I think let us take this sequentially only. That would be great. Sources of information about Earth's interior. So how can we basically, you can start with that, how Earth was formed after 13.6 before 13.6 billion years ago, and how gradually things have evolved with the different phenomena like sputtering was there, degassing, and several other solidification and cooling of the Earth's surface. You can talk about these things in the introduction. Then what we can do is we'll start as to how do we get to know about the interior of the Earth. Humans till now have not been able to reach to the interior of the Earth entirely because of the conditions that are existing within the interior of the Earth. We may not be knowing the exact reason behind it, though most of it is certain, but we are very much sure that it is very hot inside. And if there are very hot and warm conditions inside, then it is not possible for the human to penetrate that deep. So how do we even get an idea that what the Earth is actually made up of, how it is inside? Let us see. There are broadly two categories of the sources by which we can sort of corroborate, correlate, and confirm as to what is the nature of the interior of the Earth. First is the direct sources. Rocks forming from mining and drilling provide limited information about the upper crust. This is one. When you are, let us say, drilling into, this is the top layer, then you started drilling. There is an extent to which we have drilled into the Earth's surface, and we see that there are different layers that are found. And the composition of these layers is also very different. the composition with respect to the geological matter that is found, the composition with respect to, let us say, temperature conditions, with the nature of element or the nature of matter that has been found. We see that in the top layers we would experience solid matters or solid materials to be found. In the lower layers we might see the matter to be more of a viscous nature. If we go deep inside, then it can be in a solidified gas form as well. So there are different states within which this geological matter is found. So it is, first is the rocks that we are drilling, which is responsible for which is basically giving us an idea as to what the earth is basically formed of. Second is the volcanic material. When volcanoes erupt, what they basically do, volcanoes, they erupt due to the cracks that develop on the earth's surface, and they are basically like a pipe structure. So there was lots of energy because of the heat or the radiations that are happening within the deep of the earth. So it was exerting lots of pressure, and somewhere it found some cracks and some loose land, because of which this whole thing, this whole energy that was there, it started moving out in the form of a volcano. We see that this is how a volcano is generally formed, gases releasing into. So it is the material that is brought up by these volcanoes as well, in form of the gases that are there, in form of the magma or lava that it brings with itself, and also some though it may not be existing in that form in which we see at the surface of the earth, some particles which are coming. But after the study of all these things, we are getting an idea as to what all are the things which could possibly exist in the interior of the earth. So this is second direct sources which we can directly correlate to. These are limited due to human cannot reach at the greater depths. Okay? So we have already discussed this limitation of humans to dig or to certain depth only. Second is the indirect sources. These are more important, and these have given us some good amount of idea by which we can say that yes, this could be possibly a nature of. First is the seismic waves, which are most important source of understanding the earth's surface. You all must have read about those S waves and P waves, secondary waves and primary waves. So they move in this direction, they move like this way, and one is that moves by compression that medium. These are the two different waves. You must have gone through that earth shadow diagram, seismic shadows that we observe. That one is the waves which are able to move into all the mediums, and one is a set of waves which are not able to penetrate all the mediums. Let us say it is able to travel in only the solid mediums. So we got some idea that these waves, which they do not move into the liquid mediums, they can only move into the solid mediums. So what happens that they throw these waves, and sometimes they are also generated naturally. So we experience that some of the waves, if they are forming this way, and there is a pattern, there is a shadow zone of these waves, that these will not be found between this extent and this extent. Why? Because this is the farthest that these waves can go. These can go here as well, like this as well, but this is the farthest. This means that there is something inside through which they cannot traverse themselves, through which they cannot travel. So what is it that these waves they cannot travel? It is the liquid medium. So if they are not able to travel through the liquid medium, then it means that there is something liquid inside. So this is, in a way, we can say that the indirect sources, in a way, they are confirming that the interior of the earth, it could be in a semi-liquid or a liquid form, that where several materials or several radioactive equations are going on, which are causing. Next is the gravity or the magnetic fields or meteorites. They also provide us some idea that how the gravitational waves move when they move from one medium to another. They tell us some idea. There is another, which is the magnetic fields or the meteorites. When we study some of the meteorites, we can correlate that if all of these things are formed from one unit, that let us say after the Big Bang explosion, which it is believed that Earth was formed, then it is possible that we are not able to study the Earth entirely. But if we are able to study something similar, then we can correlate both of the things. That if this is found to be in some meteorites, then there is a possibility that it is also found in the Earth as well. So this is seismic behavior. It reveals the density, composition, or the state of matter, which we have discussed. What are the different layers of the Earth? Crust, which is the outermost layer. Again, this is more of a factual kind of information, which you can refer to, that what are the extent of all these layers. Within this crust as well, there is outer crust, there is inner crust, and all these. Then the discontinuity. What is discontinuity? So we have observed that this was the crust and this was crust mantle core. But what was observed was that when we are transitioning our study from this to this, there is some kind of anomaly that is found, that neither the material that is found, it belongs to this layer, nor does it belong to this layer. So there is something in between that is different from all these, from these two materials. Then we came to a conclusion that it is found after, let us say, within the crust as well. It will be found between the outer crust, inner crust. Then it will be here. Then it will be here. So it is happening that after certain depths, these discontinuities, these anomalies are found. Anomalies, why? Because they are not similar to these things. So there is something that is existing between the two. So they have been named after the geographers who have discovered them. The Conard discontinuity is there. Morovic discontinuity is there. Then comes the mantle layer, or which goes to the depth of 2,900 kilometers. Within this, after this, we found the Repeti discontinuity, the Gutenberg. So these were all the people who have discovered these layers, of which they are named after. Then we have the outer core in Lehmann discontinuity, inner core. And this is the maximum depth which is found to be of the Earth. Okay. Mainly made of solid iron, nickel. So what is happening? Okay. So this is the pictographical representation of how these layers, they are found. The crust part, then the mantle, then the consequent depth which is found along with all these layers, then these discontinuities which are found between them. So this is how. So basically this question talked about the stratification of Earth's interior. Second, it talked about what are the different sources by which we are able to confirm that this is the interior structure of the Earth. Explain the nature and behavior of seismic waves and examine their significance in interpreting the Earth's internal structure. So we have tried to understand them. Let us do that in a bit of detail. So basically, seismic waves are energy waves generated by earthquake, volcanic activity, or artificial explosion. So there are basically two types of waves which are utilized in the geographic studies. Let me categorize that for you. One is the body waves, and second is the surface waves. Within the body waves, we have the P waves, the S waves that are there, that we will discuss here. Okay. Second is the surface waves. Surface waves, we also have the love waves, and second is the Rayleigh waves. It depends upon the nature of their movement, the style in which they move, that these waves have been categorized. Let us understand the P waves. These are primary or compressional waves. They travel fastest and reach seismographs the first. They can pass through solid, liquid, and gases. I think we must be having that diagram. Yes, this diagram from NCERT, which talks about that the primary waves, they travel all the mediums. They are the fastest to travel. They compress the medium and they are able to travel. How do they compress the medium? This is the style of their movement. If this is the parcel within which they are moving, they'll move this way. That they will compress the medium, then they'll move this way. Compress, then move till now. This place here, then compress. This is how they proceed further. This is the direction of their movement. They are the fastest. They reach at the first in the seismograph, and their velocity increases in denser and more rigid materials. So it depends upon the compression. If the compression is high, and that will depend upon the density of the material. If the density is high, then there will be more compression and it will move faster. Second is the S waves, which moves with the shear. This is how they move. This is how they move. So there is a limitation to these, that they can only travel through the solid mediums. How do they travel through the solid mediums? Because of they compress, they are able to move in that upward and lower direction only, and they are not able to move into the liquid mediums. It is because of this limitation only that we have got a good enough idea as to how these waves move. Second is the surface waves. There are two type of surface waves. First is this is P waves that we have discussed, S waves, that they moves like this. Then the Rayleigh waves. Rayleigh waves is basically they move in this zigzag type of a manner, and this love waves, they move in this manner. So this is the movement, the direction of their movement, and the manner in which they interact with the matter that is present, that we generally this you would be experiencing whenever there is an earthquake. Then you would see that the cracks that are happening in the earthquake. So this is where the earthquake generated. This is the focus of the earthquake. This is the epicenter where the earthquake was first experienced on the earth's surface. Then either it will move, there are two waves of its moving. Either it will move in this zigzag manner, because anyways the energy that have come from this place, it will be dissipated. Either this will move this way, and you would see that the surface that was there, it will swell like this. You must have seen that this way. Or this will go very randomly like this way, generating cracks into the surface. You would have seen that this will be anyways that energy is passing this way, and it will generate cracks into the earth surface. So these are the two ways by which the surface waves move. Body waves, they are inside the earth surface, and surface waves, they interact on the surface of the earth. So this is the basic distinction that is there. This is the shadow zones of the two we have discussed. S waves, secondary waves, they can only travel through the solid medium. So by their movement if it is not entering into this, if it is limiting itself here, that means there is something liquid here because of which it is not able to move. Behavior of the seismic waves, reflection and refraction. Seismic waves bend and reflect when they pass through different layers. So this is how that these waves move. Change in the velocity, that they will reflect, whether they you have seen that the S waves, they would reflect from once they have reached the liquid medium. So that is the extent of their movement, right? Second is the velocity of their movement, that within the solid medium, the primary waves which can travel over the solid, liquid and gaseous stages, it can travel all the three of them. And when it is traveling through all three of them, but it will have different speeds at which it travel, because it moves with compression and expansion. It will be highest in the solid medium and relatively lower in the liquid, and thus lower in the gaseous. Third is the shadow zones that we see. What are the significance of these seismic waves? They are evidence of layered interior. We are seeing that that these seismic waves, they are in a way, they gives that that structure, that they gives that stratification of the different layers of the earth. Second is identification of the discontinuities, separates upper and continental crust. We have discussed that this is basically an anomaly that is found in between the two layers. So we are seeing that through the discontinuities. So the seismic waves, one, they are able to chart out the different layers of the earth's interior. Second, it is discussing about the discontinuities as well. Nature of the core. S waves, after entering the outer core, they reveal that they are getting reflected or getting deflected through the solid or semi-solid medium, and it is not entering into the liquid medium. That says that the interior of the earth is liquid in some sense. P waves slow down and refract strongly at the core boundary. You see through this reflection is that it came here and it turned back. Refraction is that it will travel, but its original path, it will be refracted. It will have experienced some changes. We see that solid, liquid, it experienced some change, then it again came in its original shape. So it is the refraction of the P waves which also gives us an idea that there is something liquid which is in the interior of the earth. Earthquake studies. Seismic waves help locate the focus and epicenter. We have discussed that how they help us discover that. They help estimate earthquake magnitude and intensity as well. Very true. So in a way, these body waves and these surface waves, seismic waves, that are basically, seismic is something that is related to earthquake, that is related to the movement of the surface of the earth. And if it is these, basically why these waves were caused in the first place, because the energy that was there, it was to transfer itself from one place to another. So it went in the form of the waves. So it is basically the energy that was released which was traveling all this while. Established plate tectonics theory as a unifying framework for explaining major endogenic processes and global relief features. So what is this idea of plate tectonics? Let us deal with this thing in very detail. And first, let us understand what are the plates. This is our planet Earth, and after millions and millions of years, it has divided itself into different slabs. They were due to many of the physical geological events that happened in the past, that initially it was one planet, then it could be that it cracked down into two, then cracked down into three, four. This way it transformed itself into a planet which was divided into different slabs. And when we are talking about these particular slabs, this is a plate. It could be that this is an ocean or this is a plain area. So it is at a depth, but it is at a height. But still these two can be categorized as, again, this is at a height, this is the ocean. We can say that these two are different plates. So this is how the earth is divided into different plates. Many of the theories they came up, and by which you must have heard about the seafloor spreading theory, or which have proved this thing, that the planet Earth that we see today, it has evolved from its original shape. It has break down, and there are different slabs that have break down from one part and they have moved to other part. Now let us understand why these things are moving in the first place. They are moving because of the internal convection. This is the planet Earth. This is the core of the Earth. Certain radioactivity or reactions are happening here, because of which there will be this whole thing. It is in a state of semi-liquid or liquid state, and we see that this will move because of the energy that is there in the system, and this moves in a way, in this way, that this is called convection, convective systems. This will come out as volcanoes or something. This is how this moves. Because of the radioactivity, because there is radioactive material that is found in these different areas, and we see that it is because of these reactions that these currents are moving. These are like, we have talked about the ocean currents, that they are moving like a system. So it is like a system of those currents only, that this material, whole of this material is moving. So when it is moving, it will have some impact upon the earth or the crust that is above it, and it will also move this thing in different direction based upon the internal mechanism of it. So we see that earth shifting. You must have heard about that the Indian plate is moving towards the Eurasian plate, or India in its current shape was not always here. It was somewhere around the Antarctic, and gradually it moved here. So it is because of the internal activities that goes inside the earth that it has moved here, and now it is moving here. And that happens across the world. All the plates that are there, be it the North American plate, South American plate, the Atlantic plate, Indo-Australian plate in this side, Pacific plate, which is the biggest in this side, all of these are moving into this direction. This is moving here, it is moving in this direction, this is moving this direction, it is moving into this direction. So this is a mosaic of all these crystal slabs which are arranged, and they are moving because of the activities that are inside. So plate tectonic basically is the study of these plates only, that how these slabs are moving in relation to each other. How do we understand this whole thing? So what they have done is, basic concept, lithospheric plates are there, how plates move, driving forces, mental convection, heat driven currents in the mental, they move the plates, ridge push, plates slide away, limited, and all these things. Plate boundaries and associated landforms. So to make the study simpler, what geographers have done, that they have divided the plate boundaries into, so these are two plates. So this is some plate boundary. These are different plates. So the plate boundary is the interaction point of the two plates. So after study and after observing lots of things, they have divided the plate into three type of plate boundaries. I think, yes, they have discussed three only. First is the divergent boundary. As the name suggests, that two crustal slabs, they are diverging from each other. They are moving away from each other. And as a result of this, when two things, they are moving apart, they are creating a space out of which something that is inside and something that is holding lots of energy is in a state that it can move out, it will come out. I will explain you this with a very simple diagram. At this moment, we are studying this only. These are diverging plate boundaries. This is moving in this direction. This is moving in this direction. The magma, it came out of and it started developing into volcanoes. Then gradually it became the mountain chains. So you can make this whole as like this only. You are making it. This is how the slab was and it became and mountains became. This is because of the diverging plate boundary. Then what happened? First, this is the first type. Second is the convergent plate boundary. And understand this thing, when there are two types of plates, one is the lighter plate, one is the denser plate. So what happens is that the denser plate, it is heavier, and the lighter plate, it is a bit lighter. So when the interaction happens between a denser and a lighter plate, what happens is that the denser plate slides under. It will always slide under and move it in this way. This happens in a convergent plate boundary. When two plates are converging at a point, this is the point at they are converging. They form lots and lots of features. If we see that in case of Pacific Ocean and the Asian plate, this is the Pacific plate and this is the Asian plate. All the islands of Japan and surrounding islands, they are formed because of this convergence. When this particular slab, this material went under this, what happened? There were hot conditions, so hot that they melted all the geomaterial that was there. After melting, it came out. When it came out as volcanoes, it started forming small islands. And we see a chain of islands found in the Pacific Ocean. Second is that if the two materials that are there, if they are of equal density, then what will happen at the convergent plate boundary? This will come, they will press against each other in this manner. They came and they pressed each other, and we'll see that this is how they'll keep on pushing, and the geomaterial that was existing at the two plates, it will start crumbling and start folding, and the fold mountains are formed. All the mountains across the North and South America, they are formed in this manner. The Himalayas that we see today, there was a time millions of years back when the current Himalayas, they were nothing but, let me explain you this thing this way. This is the current India as we see, and these are the Himalayas in its northern side. What happened earlier was that, forget that these did not existed here, and what was here was just ocean, plain ocean, where lots of sediments they were deposited. There was lots and lots of geomaterial that have deposited in this region. And this particular slab, it was not here. It came from some other place as a different plate. It came here and this plate was moving in this direction. There was no Himalayas back then. Then this geomaterial, these two plates, they started colliding, coming, and this whole geomaterial that was there, it gradually started crumbling and folding. And we see it is difficult to imagine that the Himalayas that we see today Someday they were just the material that was deposited in Tethys Sea. You must have heard this term, that they were deposited in this Tethys Sea, and it is still moving, and the Himalayas are still rising to the current day. So you can understand the scale at which these plates are operating. We are not able to, like the Himalayas extent, it is around 2500 to 3000 kilometers from north, from the eastern to western, and around 3 to 400 kilometers north to south. This is the extent of Himalayas. Then you can imagine the scale at which these things were operating. So this was the convergent plate boundary. Then there is one more phenomena that happens with respect to the plate boundaries, and it is the transform boundary. We have discussed that either it is coming towards or they're going away. But there was one more phenomena that was observed, that there were two lithospheric slabs that because of the internal activities, what happened that they did not crossed against each other, but they were moving in a similar direction. And there are two ways of them moving in a similar direction. The diagram only discusses one, that they are going against, but one is that they are moving apart from. These were two plates, they are moving like this. There is another that they move in this direction but at a different speed. One is moving faster, one is moving slow. So this is the transform boundaries, that they horizontally passed each other instead of they crossing each other. What are the significance of plate tectonics? That it explains the mechanism of earthquakes and volcanoes. We have understood that how these earthquakes and volcanoes, they are formed. Because when these two plates converge, the geomaterials, it tries to find out some space where it can come out. Explains the mountain building, the fold mountains, we have discussed about it. And wait, the Himalayas formed due to this mechanism. Explain ocean basin evolution. This also explains that how the ocean basins, this is called as the hygrographic scale or something like. This is the land area, this is ocean, water is filled here. Of all the things that we experience and see on this side of the earth, there are similar things happening in the oceans as well. How? Because of these phenomena only. There are earthquakes which are releasing the material. It will accumulate here, solidifies here, cool down here, and it will become some island. It will become some plateau, it will become some mountain, or it will become some trench, because it generated that space and it forms as the trench. So there are a large number of different geographical features that are formed because of this. Explain the ocean basin evolution, explains the continental drift, that how different continents are moving apart from each other. It is the mechanism that plate tectonic explains, that due to the mantle convection that is happening in the inside of the earth, this thing is happening particularly. Explain the resource distribution as well. We will be seeing that the places which are experiencing more and more volcanoes, then we would be seeing that the material, the precious material that were inside the earth, they came outside and would be found on those places only. Interplate events. There are certain limitations of this theory, though it answers most of the things, that how different plates they interact and all. Interplate, it explains, but the phenomena that happen within the plate, it has talked about what will happen at these things, but what will happen here is something that is questionable. Sometimes there are mountains which are found, or some other geographical features which are found within a plate, which the tectonics theory is not able to answer in a very convincing manner. Okay. Second is the complex plate margins. We have discussed the most simplified, but there are hundreds and thousands of plates that exist across the world which are interacting, and in a way it is difficult and it is very complex to understand all these things all together. limited prediction. It explains those events very well, that these are the places where most of the earthquakes would occur. These are the places where most of the volcanoes, they are probable to occur, but it does not give any idea about the timing. It just explains the mechanism of it, not the other aspects to it. Unravel the lithological cycle and distinguish the major rock families on the basis of their genesis, characteristics, and economic relevance. Unravel the lithological cycle and distinguish the major rock families on the basis of their genesis, characteristics, and economic relevance. First, what are rocks? These, if we have to understand them very basically, then these are basically aggregates of the minerals that are found. Minerals, you can understand it like this, that there was liquid material that was coming out of the earth's surface, and when it solidified, it solidified into small minerals. And when these things, they came together and they solidified as one unit, then we can say they were described as the rocks. Okay. Basically, naturally occurring aggregates of the minerals explains the continuous transformation of one rock type into another. Yeah, they have defined two things. First, what is a rock, then what is a rock cycle. So we understand rocks as something to be very solid, something that cannot be changed. But when we see and study the rocks, then we realize one thing, that these are something that goes transformation. But what happens is that the scale of our observation is so limited when we compare it with the scale at which rocks transforms. The time scale is something that doesn't support us in observing those changes in real time. We hardly survive 80 to 100 days, 80 to 100 years, and the rocks, they take thousands and thousands of years to transform themselves. We'll understand what are the different types of rocks, then understand that how they transform into each other. What are the processes which actually transform them into each other? So for this thing to be understood, I think first we need to understand that what are the different types of rocks that are there. The first is the igneous rocks. What are the igneous rocks? These are the rocks which are directly formed from the magma or lava which gets solidified. We have discussed it, that lava coming from the interior of the earth. Everything on the surface of the earth that we see today was someday part of a liquid only. It gradually cooled itself, solidified itself in such a way that we see the rocks today, the rocks of today. So what happens is that how these igneous rocks, they are formed is that, yes, by cooling and solidification, they are called the primary rocks, because these are the rocks which were formed originally. Originally from what? Originally from the original material of the earth, which we see in the form of magma and lava when it comes out of the surface. Okay, these are the primary rocks. There are some examples of it. Intrusive and extrusive igneous rocks. When there are two ways of solidifying of these magma, either this is the surface of the earth, either it gets solidified, this is the crust. If it is getting solidified out on the outer surface, it would be called as extrusive. It is extrusive, that it is happening on the outer side. If it is getting solidified, and that happens, and I'll explain you how that happens, that magma was coming out of this place, but the earlier disposition of the material, it was in such a way that there was a place that was left in between the two. So what it takes for the magma to cool down, it tries to find out the earliest space which it can occupy and cool itself. It will go to the space and cool itself and solidify itself here as a rock. There are different types of it which we need not go. And when it comes out and solidifies, it becomes extrusive. Otherwise, it is intrusive rock. They are major landforms such as lava plateau. We are just discussing it briefly. What are the three types of rocks and how they are formed. Then we'll discuss the rock cycle and then the significance of it. Sedimentary, they are formed by deposition, compaction, and cementation of the sediments. So let us see that there are different particles, small particles. They were moving. We can understand like a heap of sand that was traveling this way. There was a stone, there was a tree or something that came here. This whole material got accumulated here. It started accumulating more and more material. So the lower one that is there, gradually it will start compacting, and when the overlying geomaterial it will increases, then the pressure on this rock, it will gradually compact or cement this particular heap of sand that it was initially, to transform into a solid structure which could be called as the sedimentary rocks. Sedimentary, the word suggests, formed from the sediments. Third is the metamorphic rocks, which are formed when these two types of rocks, the igneous and the sedimentary, they undergo transformation. And how does they undergo transformation? Is by two waves. That there was a rock that was there, due to overlying pressure, or some other condition, we saw that there was lots of heat and pressure that was experienced by the original igneous and sedimentary rocks. Then the whole of the thing, it will undergo some changes without complete melting. They are generally hard, compact and crystalline rocks. When existing rocks, they are changed by heat, pressure and chemically active fluids. So when the fundamental nature of the initial two rocks that we have discussed, when it undergoes a change, then we see this thing happening. Okay. So these are the three types of rocks that we have discussed. Then let us understand the rock cycle and how it works. Explains the continuous transformation of one rock type into another through cooling, weathering, deposition, heat, pressure and melting. So these were the three types of rocks that we have discussed: igneous, sedimentary, then metamorphic. So this is the natural cycle through which these rocks they undergo. That out of the original magma, when it cooled and solidified, it was formed as igneous rocks. Due to weathering and erosion, that the original rock that was there, it broke down into several pieces. And when these sediments, they deposited themselves and they became compact over a period of time, we saw that it became a solid rock again, thus called as the sedimentary rocks. There is a distinguishing characteristic with the sedimentary rocks as well, that these would be uniform in their composition, that these are formed of a material, but in their case what happens, they are formed out of decomposition, that sometimes other things also get trapped in them. Sometimes we see that that some tree branches, some tree roots, some animal getting trapped into it, and this is a feature that distinguishes that it's a sedimentary rock. Then undergoes due to temperature and pressure. Mostly it happens either when there is a geophysical activity happening and leading to this change, or some pressure caused by due to accumulation of more and more material, and pressure was caused and this again melts into magma, and this cycle goes on and on. So the rocks that we see today, they could be someday an igneous rock, as the sedimentary rocks that we see. The igneous rock that we see today, they could be metamorphic rock. They have gone through the process of metamorphosis, and they have transformed into themselves. So these are the ways by which this whole cycle works. Magma to igneous, weathering and erosion that happens. Then we sedimentation, lithification, these different types. Okay. The next is about decode the geomorphic processes of weathering and classify its major forms with their controlling factors and significance. Decode the geomorphic processes of weathering, and classify its major forms and their controlling factors. So what is weathering? Weathering is basically the breakdown, in situ breakdown of decomposition of the rocks. If there is a rock, it is getting fragmented or segmented into different particles, then it is categorized as the weathering. And it occurs due to atmospheric, biological, we'll discuss these things, that how these weathering happens. So whenever a rock breakdowns, in situ is, there is ex situ or in situ. In situ is when the rock breaks down at its own place, then it is the in situ, and it is in such a situation that it is called as weathering. When it happens over a let us say an extent, then it is called as the. What are the controlling factors? First is the climate. Climate is one of the biggest factors because of which the rocks undergo transformation. First is the temperature conditions. You must have heard about the onion peeling. What happens in onion peeling? That this was a rock. What happened that due to the hot conditions, due to hot temperature, the particles of the rock, they expanded a bit, very small, but expanded a bit during the daytime due to experiencing. Due to cold conditions during the night, they will contract. This expansion contraction cycle that goes on for years and years, what happens that this top layer, it breaks itself from its below layer and it goes. So this is called as the onion peeling, that gradually these layers of the rock, they come down, and what you see in the end is a very small rock. And it happened because of the onion peeling. It happens because of the temperature changes that it experiences. Hot and humid, it favors chemical weathering because of the availability of water as well, that it either decomposes, certain chemical reactions might happen. You must have heard about the carbonate reactions taking place, oxygen interacting with the rock material and this thing transforming itself. Then cold and dry climates, they favor physical weathering that we have talked about. The chemical weathering generally happens. You must have seen rocks with different structures because of the chemical reactions that takes place with that. Rock structure and composition. Second feature because of which this weathering happens is because of the rock structure and composition. The joints, fractures that are found within the rocks, they are also to an extent, they regulate this thing. Minerals like feldspar, they weather easily, while quartz is more composed. So this is it. It would be the geological composition of the rocks as well, which will determine as to how they are going to react. Relief and slope is the next thing, that how the rocks are placed, it also determines that the steep slopes promote removal of the weathered material, gentle slopes allow deeper weathering profiles. ठीक है. Plain and humid lowlands, they often develop thick regolith. So this is the plain area. This is the higher steep area, and it also depends upon the slope or which impacts it. Then this is the plain area. It weathers from here and it deposits here. So gradually what we see is that earlier it was this type of a structure. Gradually it declines like this. This is called as back wasting of a topographical feature. That is, it undergoes like this way. So it gradually, you would see that a mountain that was standing, the example of Aravallis becomes very important, that it gradually recedes. Next is vegetation and organism. Sometimes they widen the cracks, and this is what happens. Longer exposure increases the depth and intensity of weathering. Time is when we are talking about geography particularly, there are two things which becomes very important. The space determine the existing conditions there, the climatic conditions, the temperature conditions and all that. And second aspect is the temporal aspect, that the time at which all these activities, all these processes, these phenomena, they occur. Type of weathering, physical weathering. It involves the mechanical breakdown of the rocks. We have discussed the onion peeling of the rocks. Major processes, insolation weathering. We have discussed that, heating and cooling. Second is frost action. This also happens that water enters inside the cracks of the rocks and it expands. Ice expands itself. When water enters into the cracks, and then it will expand the cracks. So this frost action also leads to weathering. Exfoliation, we have discussed that how the outer layer, it gradually peels off. Salt crystallization, salt crystals grow into rock pores and break them apart. Okay. Impact on the earth, it produces rock fragments, creep, prepares. So the plain areas that we see today, they are because of these breakdown only. That the mountains, they break down gradually, the rivers brought them down and deposited for thousands and thousands and millions of years, that the plain areas that we are residing nowadays are a result of those activities. Second is the chemical weathering. It involves decomposition through chemical reactions. There are different ways. Solution, that soluble materials, they dissolve into water. Carbonation, that different carbonic acids that are available into the atmosphere because of the presence of carbon oxide and others. Karst features, the karst topographic, it is because of this process only, carbonation. Hydration, minerals absorb water and expand. Hydrolysis, oxidation. So these are the different processes by which these things takes place. Impact, it produces different kind of landforms like sinkholes, stalactites that we see. Biological weathering, this happens due to organisms, animals and all that. Impact, significance of weathering. First is soil formation. We have discussed that how the current soils, they all are formed, and all of them are a result of the weathering of the rock material only. Landform development, cliffs, caves, all these things, all the shapes of the landforms that you see, whether the mountain was supposed to be like this, but what you see is a mountain like this, because this whole part, it got eroded in due course of time. You must have seen some mushroom rocks present in desert areas, because the wind that moves in desert areas, it gradually depletes this rock and makes it into a mushroom rock. Mineral formation, because when the bigger rocks, they break down, the minerals that we see, they come because of that only. Human relevance, agriculture, construction, mining, and all the set of activities which involves any physical material, it is because of the weathering that happens of the. This is it for today. So we will discuss the remaining question in the coming session. Okay, thank you so much.